Testing. We're going to get started in 2 minutes, folks. We're going to get started in 2 minutes. We're running just a little bit behind. All right. Okay. Well, let's get started, folks. Welcome. Happy New Year. Really excited for all of you to come here for this great evening of web virtual reality. So let's see. Let's kick it off here. Right. So we have a couple of big events combined. So when we started this event, we were planning this a while back. Tony hit us up and said, let's do a big event about web-based virtual reality. And we got everything together. We're about to post our event for tonight when we had the event, the venue locked in and everything. And it turned out that there was another event happening in San Francisco. So I was like, uh-oh, let's do something about that. So we decided to collaborate. There's this great event at the Metreon, which is not far from here. And so we kind of cross-promoted both of these events. And it's a great opportunity for everybody to go after this event to the Metreon. And we're actually providing a bus service for everyone to go over there. Now, the bus can only hold about 50 people, but it will keep making trips until everyone that wants to go is there. So definitely, we will have a pretty tight schedule. We want to be done roughly around 9 o'clock, and then head over to the Metreon for the big VR expo. There's going to be about, I don't know, 1,000 or 2,000 people or so over there. It's going to be quite something. If you don't have a ticket for that yet, you can buy it there at the door. Use SFHTML5 as your coupon code. And then you can get $10 off the price. I think it becomes a $15 ticket at that point. There's great music there, some of San Francisco's best DJs, and lots of demos, and it's going to be pretty epic. All right, so how many of you are new members of SFHTML5? Okay, welcome, welcome. And also, welcome to all the folks joining us on the live stream. So for those of you that don't know, we've grown in almost 5 years. In March will be our 5th anniversary we're now just a couple of people away from about 12,000 members. We've been around for close to 5 years. And all of our events are video recorded, and also a lot of them are live streamed. Now, you can find the complete archive of all of those talks on at bit.ly SFHTML5 videos. And definitely check that out. And the meetup, just tell your friends to join if they want to be part of these events. We're also, typically the recordings are available online in about a week or so. All right, now a couple of thanks to some of the folks that are sponsoring here. We have Alcademics back after the great success at the Christmas party. A big round of applause for Alcademics for the cocktails. And also back is Grant and Eddie, the wine tasting. If you haven't had some of their wine, check it out at the next break, which will be a short break. So a round of applause for Grant, Eddie. And the music tonight, back by popular demand, Rocky, my son, he will also be playing at the Metreon at about 9:40, so get there early. That event, by the way, is going on till about 1 o'clock in the morning, so that should be quite something. Okay, one more round of applause for Google for hosting us, for feeding us, and just putting on this great event here. So, okay, we have a few other sponsors that we'd like to thank. So, Kazing, one of the founding sponsors, real-time web technology. They're usually hiring. Talk to Vanessa if you are interested in WebSocket technology or anything in that real-time arena. Modern IE, ClearSlide, Twitter. Fluent is back this year. It's on in April. If you can get your tickets, you can use discount code SFHTML5, and we'll have a few raffle tickets, raffling off complete conference passes, and those are in the like $1,500 range. Leap Motion is here, and they're going to say a couple quick words, 30 seconds.
Fantastic. Hi, I'm Peter. I maintain the Leap Motion JavaScript library. As you guys may or may not know, this lets you get Leap Motion data onto a web page without any plugin or anything like that through a WebSocket server to your local machine. And it allows you to do pretty easy things pretty quickly, like getting a hand onto your web page in WebGL with 3JS in a single line of code. And some of our newer efforts have been around interactions, being able to pick up and move things around. So exciting things. Come check it out. That's it. We have a booth.
Hi there. I'm Iker from Lude, and we offer a platform for HTML5 developers that they can port their applications to mobile devices. We are for general purpose applications, but also, and today where I'm showcasing is mostly WebGL-based games and demos. We were the first to offer, and still the only ones to offer WebGL support for iOS 6 and above and Android 2.3 and above. Our platform allows you to build applications even for Android Wear, and I also have a couple of demos, not for VR today, but something that you could build similar, and also for AR. So if you want to come to our booth, and I will be more than happy to talk to you.
Thanks, Igor. All right, a couple of other sponsors. Sony, a couple of people from Sony are in the house. If you came in, you probably have received a raffle ticket. We have some great prizes. We have some books, some wine packages, and also a bunch of tickets to various conferences. So we'll be raffling those off at the very end, about 10 minutes to 9, and we're trying, like I said, to get out of here at 9 o'clock. All right, so once more, for those that just came in at the very last minute, we have a bus that is taking you for free to the Metreon. Entry there, if you don't have a ticket yet, you can still get a ticket there for about $15 if you take the SFHTML5 coupon code. It should be a great event that will last till about 1 o'clock. So, all right, without further ado, I'd like to get into the talk. So, really excited about the capabilities that are coming to the browser for virtual reality. And Tony Parisi, our speaker from last year's, the biggest event we've ever had about WebGL, is here to sort of kick it off, give a bit of an introduction. And then we'll have 4 other great talks from Google and Mozilla, Dodo Case, and I'm forgetting one. Leap Motion, of course. All right, great. So, Tony, take it away.
Thank you, Peter.
All right, thank you.
Hey, everybody. I think that might be a little loud. I am the co-organizer of the San Francisco WebGL meetup group. We meet regularly, and we have about 800 members, so we're pretty solid. We've reproduced recently. We have a Silicon Valley spin-off, so if you're actually based in the peninsula of Silicon Valley and want to go to meetups down there, look that one up on meetups as well. And we recently also created a web VR meetup group to talk about the topics that we're going to look into tonight. A year ago, almost to the day, I was up here on this stage, thanks to Peter and folks, and made the somewhat audacious claim that WebGL would be everywhere by the end of 2014. And guess what? I was right. We were right, and the people who believe and the folks who had been backing WebGL and investing their time and energy into it, our investments have been paid off big time. WebGL is on iOS 8 and up. Basically, it runs on every device, anything you can think of on the planet. 3 billion WebGL seats out there. That is awesome. What happened in 2014 was that there was some bigger piece of news, which is that virtual reality has hit the stage, as we all know, with Oculus being purchased by Facebook, sort of getting this thing to explode. And so what we're going to talk about today is how these technologies are on a quick convergence course. So how many people have had a chance to play with an Oculus Rift? Good, pretty good, about half of you. It looks like this if you haven't seen it. This is the latest developer kit. You can buy one for $350, not too bad, and you can build applications for it using their SDK, and we're going to get into how you build apps in a second. Have people heard of the Samsung Gear VR? So this was just released in December. Samsung did a partnership with Oculus. They licensed some of their technology, including the optics, for the distorted lenses to give you a mobile VR experience. I mean, Oculus is great, but you're actually connected with this cable, as you know, at least the current editions here, and it's kind of clunky, and you have to hook it up to some big honking PC or the best Mac you can buy. It's it's not a very mobile solution. So Samsung's built this mobile thing, but it's a $200 headset, and right now you can only drop one phone into it, and that phone is the Samsung Galaxy Note 4. If you don't already have a Note 4 or weren't planning on buying a new phone and getting a new plan, you're talking about spending $800 on the phone plus your $200. So not exactly the low-cost kind of solution we might want yet, but it's really amazing. I needed a tax write-off at the end of 2014, so I said, okay, I'm going to splurge. So I bought a Note 4, I got my Samsung Gear VR, and this thing is awesome. The apps are beautiful. There's this wonderful little sort of channel changer, way to switch between apps. It's called the Oculus Store. And it's just beautifully designed. And I highly recommend you try one if you don't want to go out and buy one, because they do cost a lot of money. And then there's this thing called Google Cardboard. I don't know if the idea was, kind of a slap in the face to Oculus or whatever it was back a year ago or so when that acquisition happened. But shortly after Oculus was acquired by Facebook, Google at I/O last year came out with this thing, which is a little cardboard box that you can pop your smartphone into. The box costs about $2 in parts. Plastic lenses, cardboard tape, and then folks make them for about $20, $25. You can just buy the stuff ready to go to assemble, so you don't have to cut it and find all the pieces. And Dodo Case, the last speaker tonight, is going to show you Google Cardboard. So that's super cheap, and it works on any phone you got today. Now, it doesn't have quite the same wide field of view that an Oculus does. It doesn't track as fast, and you'll see all that. And it's more for the lightweight little tastes of VR, but it's kind of amazing that you can do all this for just a few dollars. So we have a lot of consumer VR potential here. Imagine Samsung Gear VR gets cheaper. Imagine Oculus gets their form factor together for the retail set they'll ship at some point. And imagine Google Cardboard sort of growing up to be maybe more durable cases you drop your phone into. So very exciting. But let's talk first about how VR apps are built today. And this is what's going to be interesting to the people in this room. If you go out and try and get an app for Oculus today, mostly what you're going to see is a site full of apps to download. And I mean apps, like 300 megabytes of stuff. If you're doing it on Samsung Gear VR, you actually have to go through an app store and do an install. When you build your VR, you're building it with a tool like Unity, and you basically got a proprietary stack. Unity is great, and it even publishes to WebGL. That's a sidebar. We'll talk about that later if we have time. But mostly you're using proprietary tools. And in general, it's a closed culture of sort of game development style ways of building VR. And you need to be an expert in 3D graphics. This world we're seeing already is almost like console gaming and mobile computing, the mobile market have had an evil love child, and they're sort of replicating all of the things that we've been seeing with app stores that the mobile web is trying to undo. So it's a very interesting situation right now. And the folks in this room are here to try and offer a different alternative that's more like the web. And we know why we like the web. We like the web because we don't need to download apps. Someone sends you a URL, you hit the link, and you see the page, right? There's nobody gatekeeping. You don't have to install an app. When you're creating your content, you can publish it instantly in the cloud, and you can use any choice of tools and open source technologies to build things. So it's a very different world. And in general, this is a world with no barriers to entry. So imagine, everyone loves VR now. People are super excited about it. I go to these VR meetups, and 90% of the people in the room are not Unity developers. They're not game developers. They want VR to go visit other places, to go take a walk through a Tuscan village, to go, do an architectural recreation or historical recreation for somebody. And guess what? Most of the people that do these kind of things don't actually have any money. Let's say you're the Museum of Science in some town, Poughkeepsie, New York. I don't know if they have a Museum of Science, it's just a guess. And you have, you want to build a little planetarium exhibit. You've got 2 people, 2 months, and no money. So you can't hire a game development team to build this stuff for you. So, imagine if we could bring together the web and VR. Maybe we can have the chocolate and peanut butter, the Reese's cup, if you will, of this kind of new experience, which is virtual reality created with open web technologies. And that's what WebVR is all about. With WebVR, you build your apps in JavaScript. And they render in WebGL, which is everywhere now, like I said. Now, what we're going to see tonight is that there are new builds of the browsers. If you go, we have links for this. You can go get builds of Firefox and Chrome that have VR support. That's essentially 2 things. It will head track the Oculus Rift rotation. And this could work on other headsets too, but it's being built for Rift right now because that's the predominant one. And it will do the stereo rendering and distortion if you go into full screen mode that you've seen, like we see up here. That's what your actual image looks like until it's assembled, in the Rift for your eyes. So the browser will do this stuff for you automatically in a full screen mode. What does that mean? Let's assume someday the browsers just have these features built in. You no longer have to go to an app store to experience VR. You no longer have to download an app. Now with mobile and Cardboard, we can just add a smartphone. This actually works with today's browsers. All you need to do is WebGL rendering 2 images side by side, not even with the distortion, and just use the regular device orientation that comes with your phone and that works in a browser. And you can do it in a browser or in a hybrid HTML5 mobile app, like with some native code around it if you want to make an app instead. So there's a site up there. Josh, who's the next speaker, is actually going to show you this stuff in a minute, so I won't get into it. But Mozilla VR was the first out there with this. And here's the awesome thing is that Mozilla and the Google team are kind of working in lockstep on this. They have the same APIs they're building to. So this site will work with the Google Nightlies as well. But if you go to mozvr.com, you're going to see some wonderful experiments of a first attempt at visualizations using virtual reality. This is a screenshot from a project I worked on, myself and a fellow named Eric Levin, who's a creative coder in the city. And we built this thing working with Josh Carpenter from Mozilla to basically do a fly-through of an information landscape. And then Josh put a really nice front end together with his creative team to basically give you a way to navigate from VR scene to VR scene. And I think he's going to show you that in his next talk. So real quickly, and Brandon's going to go into details on this tonight, we're going to talk about the API itself. As I said, it's the same API. It runs in both of these browsers right now. I hope other browsers will support it at some point. What you do in your JavaScript code is the first thing you do is ask the browser, navigator.method name. Brandon will show you later, I've forgotten. Get VR devices, is that right? And you get a call back from that method, and it's going to give you an enumerated list of the VR devices you have at your disposal. So if an Oculus Rift is connected, it's going to tell you. And it's going to give you a device for doing the stereo display, and it's going to give you a separate device for the positional tracking. And you're going to use those in your JavaScript code to render and track respectively. If you find the VR device for rendering, you do a set full screen on it. Just like the set full screen API, you already know if you've done full screen HTML, but you pass it a VR device as one of the arguments. And then during your request animation frame loop, everyone knows what request animation frame is at this point in 2015? Yes? No? Hope so. Anyway, when you're doing your animation, that's when you want to actually query the device and find out the latest position and orientation the Oculus Rift, the DK2 will actually track position if you mount a camera on your computer. And if you're like me and you don't want to code in WebGL all day long because it's a hard API to use, you're going to use a library like 3JS. 3JS actually has 2 objects that come with the samples now from version 68 and up, where you can just go get sample code that gives you the stereo rendering effect and the tracking controls. So that's pretty awesome. It's even easier with Cardboard. So here's some links, and I'll have these slides up online so you can see the Google Cardboard Showcase if you haven't checked it out, Chrome VR. Like I said, you just render the images side by side. So what that means really, if you don't know your 3D, is you have 2 cameras. You point the camera at the scene from one place, and then you offset it, well, just exactly the distance your eyes would be, or most people's eyes would be, which is about 6 centimeters-ish. Anyway, you draw the scene from 2 cameras. So you render that on each side here. These are 2 images from the gallery that was created by Mr. Doob, fellow who wrote 3JS. And that's a way to navigate through different scenes. When you look at a tile, that little cursor will tick down and launch your application. So that's there. And all you have to do is that and use the device orientation API to actually track where the camera's looking. And that's it. And Google was giving out cardboards out front there, so I hope you guys got those if you haven't already. And the folks from DodoCase make a really great cardboard viewer. And there's about 500,000 of them out there or something. So, you know, people are picking up on these and they really like them. So, you know, that's kind of it. The rest of the speakers are going to get into some details for you, but I want to kind of speak to you about some of the challenges and where I think we are at. So when you play with WebVR on the Oculus Rift, I think you'll agree, you're going to see some of these experiences tonight. They're kind of experimental, not quite ready for prime time, but it's okay. Neither is the Oculus Rift. Apparently, they're not going to ship a commercial headset till about 2016 is the latest. Early 2016, I'm hearing. Then I've heard late 2015 at CES recently. Maybe they're hedging now, but it's not going to be for a while. If they say early 2016, you know it's not going to be a day before that. So we've got some time, and you know, presumably the browsers will just get better and keep tracking with that. We're still seeing issues with latency. So one of the big things about virtual reality, if you've tried Oculus Rift, is especially the lower res ones and the slower ones, like the earlier developer kit 1, is that as you turn your head, if the image isn't catching up with you, you can get a kind of motion sickness. So the real goal in application development is to get to 75 or 90 or even 120 frames per second now, is what the folks from Oculus are saying is a good responsive VR application that makes you feel like you're always there. So current browsers, just you got to kind of sync your browser up, otherwise you get really janky effects, and that's it's throttled to 60 frames a second. Brandon, did you guys fix that yet?
In some cases, I'll talk about it.
Yeah, so Brandon's going to talk about where they're at on that, but if we can unleash that and essentially get rid of this artificial barrier to frame rate, then that'll be we're going to be in a better position to render VR apps fast enough to have a good experience. And of course, we get clunky software installation and drivers and all kinds of installs, and hopefully a lot of that's going to get cleaned up. With Gear VR, to build WebVR today, I've been seeing things on the mailing list that are out there. People are starting to try that. I just bought my Gear VR, so I'm going to try it soon, which is to be able to put together WebVR into the Gear. But you got to do it with a hybrid application, because the Gear VR actually has a separate motion sensor. It doesn't use the one that's built into the phone, the accelerometer of the phone. So if you use the device orientation API that comes in your browser, you're not getting the right sensor. You need to actually talk to the other one. So what you would do is you'd build a hybrid app. You'd build native code that talks to that sensor using the Oculus SDK for mobile. And then you'd render with WebGL using all your HTML5. So most of your app could be written in HTML5. I don't know how well this is going to work. I hope to be able to report on this in the next couple of months. I'm actually going to start working on it. Cardboard's ready to go, actually. This is the fun thing, though. The 500,000 headsets out there, that's going to grow and grow and grow, because people are doing things like advertising stunts with it. They're, you know, taping at concerts. There was this Paul McCartney concert that was just done and a Jack White concert filmed in VR. So it's just stereo video. It's not interactive graphics, just video, but viewable in Cardboard. And they've just given away a bunch of these things at events. And so we're going to see more and more of these Cardboard viewers out there. And I think that's a really exciting way for all of us to get started on VR, where it can get in everybody's hands this year. So that's really great. One of the big challenges on VR right now is input. So if you have tried an Oculus Rift, I won't put the song because I got this mic on, but if you tried it on, you got this thing on your head, you are now blocked off from the outside world. And if you've done a lot of these Oculus demos, a friend of yours is taking your hand and like putting it on the WASD keys, or like putting a game controller in your hand. And we all know how to use, I think, an Xbox or PS4 controller now, so that's the good news. But putting that in your hands, or as David's going to show you tonight, there's leap motion input that's starting to happen, but it's pretty challenging still. We don't have the mouse of VR yet. And so, we're literally flying blind when we strap into these devices. And so that's going to be an interesting area over the next few years, and one where the browsers could be challenged only because browsers don't have a kind of generic way to get input from devices via USB. So we're gonna get into a situation there, but let's take it as it comes. And the tools are really rough. There aren't really good development tools for WebGL yet, and that's where the sort of rubber hits the road. I'm going to just quickly tell you about a project I'm working on. It's called GLAM, for GL and markup. So I've actually made it so that you can just use markup tags in CSS to make 3D scenes. And so there's the GitHub repo. You can go check it out, or check out the demos at glamjs.org. And it's literally to make a scene like this with a panoramic background and bubbles that you can click on and they go pop. It's really sweet. You just do this much CSS, this much markup, and I wrote about 20 lines of JavaScript code to randomly place bubbles. So instead of doing it, if you've done 3JS development, it's lines and lines of code to just kind of string together your scenes. I thought it would be really, really good to have a declarative markup way of doing this. And turns out I wasn't the only one. There's another project out there called Scene VR, and this guy Ben Nolan and I are talking right now to see if we can just use the same set of tags. So that's pretty exciting out there in the tools front. But we're still new and evolving. I mean, I got to admit, the situation on native app development for VR is much better because you've got a tool like Unity that's really ready to go. Whereas in the open web, you're going to be stringing together a bunch of things with 3JS and building your own tools pipeline. But I promise that will get better over the years. These are going to be up on SlideShare, so you get a list here. I made a quick set of examples that are up on GitHub that are just simple 3JS and JavaScript for making WebVR. Here's the links for the browser dev builds. These are not in the nightly channels yet. Josh, has that changed? Okay, Josh will tell you about where Firefox is on this, but so you have to go get a specific build. It's not the Chromium Nightly or the Firefox Nightly yet. That Moz VR showcase, Josh is going to show you, and the Cardboard VR showcase. And then there's a mailing list. If you really want to get into these subjects, go to WebVR Discuss, subscribe to that, and there's, I don't know, it's not too noisy right now, a handful of messages every day, really exciting chatter. And then one quick announcement, and my friends in the room probably, this is the time where they're going to come up and examine my head. But I've just signed up to write my third O'Reilly book, and we're going to try and get it out roughly in May, and probably early release for Fluent, which is in April this year. And this is going to be a very high-level book, and it's also going to talk about native and web VR stuff. So unabashed plug for this, but if people want to get into this more fully, this would be a great place to start. Or if people want to help me write and review the book, come find me afterwards. I'm really excited about this one, bringing the word to the world. All right, so with that, I'm pretty much done. So I would love to bring Josh up here. You ready, Josh? Yeah, sort of? Good. All right.
Yeah, good? Okay.
We need to switch up video, right?
I'll take that.
So back in around May last year, after that Oculus announcement, there was the first virtual reality conference in Silicon Valley. It was called the Silicon Valley VR Conference. And I met this fellow, Josh Carpenter, and he came to me and he said, we think this Oculus stuff is great. We're thinking about building support into our browser. What do you think of that? I said, that sounds like a really good idea. And so we stayed in touch on that, and 2 months later, Josh showed up at our WebGL meetup and showed off an early version of this running in Firefox. And guess what? Brandon Jones from Chrome also showed up at the very same meetup and showed the same stuff running in a Chrome build. So we're talking already 6 months ago, those folks have been trying to get their APIs working together. and WebVR working in both browsers. So that's a real testament to collaboration, and it's been amazing working with these guys. So Josh, are you ready?
Yeah, just about.
Good to go? All right. Josh Carpenter, everyone.
Hi, buddy. Yeah. Folks, I apologize. Just need to give me a second here. I'm trying to get the riff to want to play nice. No device attached. That's not good. I've had like oh, hey, there we go. I've had a streak of really good luck doing these kind of demos, and I just knew that tonight it would just come to a screeching and flaming halt. But it looks like we might be okay here. Out of curiosity, like, who here has an Oculus? Okay, all right. Has anyone here tried MozVR or tried WebVR yet? Okay, cool. So Tony was totally right. He suggested I kind of show you some of the things that have been built so far, because for some of you it may be the first time seeing this. I'm actually going to get my water. I'm going to walk and talk because I can totally do that. Thank you. So my name is Josh Carpenter. I'm a Mozilla employee. I'm one of a very small team at Mozilla working on WebVR. My partner in this is Vlad, Vlad Vukcevic. God, I got to get better at that. And Vlad was a co-creator of WebGL. And so Vlad and Brandon, over the past summer, created these APIs that Tony was referring to that have enabled all of this. That was kind of the starting gun. And really what I want to talk about today is where do we go next? And what is kind of the next logical progression in the step towards the metaverse, if you want to think of it that way. Or if you just want to think about how can we make WebVR a little bit less painful, a little bit more creatively empowering for developers. So I'm going to hop around between 4 different tabs today and then a bunch of preview slides. This is going to be just awesome, and it's probably going to explode. So, all right, so what can we do today? I'll show you MozVR really quick. This is the site that we made. There, right off the bat. All right, let's see here. Boom. Is this it? Yes. All right. All right, so this is the site that we made internally, and really what our goal here was, well, just for me, it was just I should really learn WebGL and 3JS if I'm going to work on this. I previously was lead designer on Firefox OS, which is a web-based operating system. So we really thought deeply about, what is the web really special? What makes the web special? What would you want in a web-based operating system? But to me, WebGL was pretty new. Done a lot of 3D, a lot of motion graphics, but our teams had to get acclimated with the tool set. The second thing was we wanted to try and explore what VR browsing might actually be like. So what we have here on this site is if you have a VR version of Firefox, which you can get from mozvr.com, we have a site that essentially is a collection of demos created by ourselves and a bunch of partners we worked with, including Leap Motion, Tony's team, pretty amazing documentarians, the LVR team, who are phenomenal. They're based in San Francisco as well. We made a bunch of individual demos, and then MozVR allows you to actually browse through them. I don't have the camera hooked up here, but essentially this is kind of like web design as architecture or space planning. As a designer, this was a pretty phenomenally, mind-blowingly fun process, trying to figure out, how do I fill this space, and what does a link look like? How do I interact with things in a 3D volume? For example, I don't have the camera, but that text is pretty hard to read in a DK2, that little instruction panel. But the wonderful thing about virtual reality is you can actually lean in and read it perfectly. So the implications for interaction design are just mind-blowing. To have someone able to walk around your space or physically lean in and read text and things like that. Interaction model is really basic. We look at things and we click on them. We're working on a more elaborate cursor, but for V1, MVP, this was the way to go. So if, for example, I want to maybe play this documentary, I look at it, and with my gamepad or with my mouse, I can just click on it. We play a transition. We say a little bit about incoming site, and the incoming site gets pulled in. Everything you're seeing are being pulled off of GitHub servers except the actual master itself, which is running off my local host, but this is all running at mozvr.com. You're essentially seeing, for the technical in the audience, you're seeing 2 iframes stacked on top of one another. The top iframe presents the HUD, the UI, which I'll show you in a second, and the back iframe shows you what you're seeing right now, which is the content. And by stacking these 2 iframes and kind of covering up the back with the front, we can approximate the look of actually browsing from site to site to site seamlessly. So that transition you saw, that kind of black-white with that white grid, that's kind of a site transition we're playing with. So this is a documentary being made right now. This is the LVR WebGL video player. This is just an MP4 equirectangular mapped onto a sphere, really straightforward. This documentarian team contacted me out of the blue And so we've got this amazing documentary. We'd love to give you the trailer for this. So this is being shot in the Arctic right now, and it kind of shows the educational potential of virtual reality because this, could transport a student into a place in the world they would never normally go. One of the things I love about VR, its potential is as a tool for empathy. Like nothing else, it could make us feel like we were in these places. We're actually, in a place like West Africa in an Ebola crisis, or in the north, and actually witnessing a change in the Arctic happening right now. So the part we're really proud of with Moz VR is now if I want to change sites, I don't have to exit VR. I don't have to type in anything into the URL bar. I can just hit spacebar. And we've got this heads-up display. And essentially, the heads-up display just lets us look at these links and click on them. So for example, I want to go to Seashell here. Click on it. Again, we have a site transition. And we just go from one scene to the next. Totally seamlessly. Again, no need to take off our headsets. Virtual reality from day one is going to be mobile. Oculus has said they'll have desktop capability, but also I think the default will be mobile, which is to say all-in-one, which is to say you never want to have to take off your headset to do anything. So it will not be tethered like it is right now into this desktop. So it's really important for the web to have that capability and for us to start thinking about that now, which I'll say a lot more about in a second. So again, you can go to mozvr.com and see all this. It's all up there right now. There's a limitation here, which is pretty obvious. You can't go anywhere from anywhere. You can only go where we let you go. You can only go to the links that are actually in this heads-up display. So that's one of the things I want to talk about today. One of the things we have to figure out as a community, how are we going to let people go anywhere from anywhere? OK, so mozvr.com. Just going to close that. OK, so the web, the strengths of the web. Again, I mentioned the things we really love about the web. It's decentralized. It's completely ubiquitous. Interoperability, safety, openness, links, which are fantastic, and then ease of development, which Tony really touched on in a great way. There's been a lot of hand-wringing about the decline of the web, or you'll see some kind of what I would think are misinformed articles about the decline of the web because the browser has declined in proportional market share of time spent on our digital devices. I think that's ludicrous. The browser was never the web. The web has speciated. It's divided into a million different life forms and manifestations, from RSS feeds to push notifications to embedded web views to any number of different touch points. Like everything that we interact with is the web. So the web has won utterly and completely. It's succeeded beyond our wildest dreams. It was never just the browser. So I think the web is in an extremely, extremely strong place today, as this slide says. And virtual reality is mind-blowing, but as Tony pointed out, there's a couple things that I think we would all agree are shortcomings with early VR. Fragmented market. It's so easy to make a headset, and these handset manufacturers are highly motivated to because many of them are facing pretty declining profits. So you can make the hardware is easy. Some of it's even open source because Oculus has been very good about open sourcing some of the DK1 stuff. So we're looking at kind of an uncertain roadmap and a fragmented roadmap. Probably a lot of different headsets out there. A high skill level for even a basic project. You got to use Unity or Unreal for the most part. Consumption, you have friction. There's installs, and God knows what's in those installs. You got to go to Oculus Share or something like that. And then lastly, private sector control. I am not an ideologue about open. I like a mixed stack of open and closed, and lots of economic opportunities for everybody. I believe very strongly in that. I like app stores, and I like open. I like suburbs, and I like downtowns. But I think that right now we're kind of tilted, obviously, pretty far in the private sector control side of things. And I think VR's too important. It's a medium. It's too important to leave any one company, any one entity. So I think we want to see an open layer there across VR. And I would argue that most of these organizations want the same thing. I know Oculus is embracing WebGL, I think, for the sake of their desktop distribution interface, although it's all rumor and hearsay based on Connect. But I think they would agree that we want an open layer across all of this. So looking at the strengths of the web, and then looking at where VR right now is maybe a bit, has some holes in it, I think we would agree that we want it to be more webby. So I want to be able to go anywhere from anywhere instantly. So no longer having these hermetically sealed applications that have very little, if any, awareness of one another, but a VR of links, of small units of content bound together by links, and moving between those, and in a way that's safe. These user agents, these browsers are nice sandboxes, and they keep us safe most of the time. Ease of development, obviously. I can make something, share it with everybody, and I know that no matter what headset you have, you can actually fire it up and it'll work on it. And then tapping into that massive long tail of web content. There's billions of websites. Let's make it easy for devs to leverage it and bring it into the applications. And lastly, like I said, interoperability. I talked to an executive in our company, and who will go unnamed, and I'm like, we got to start working on a browser. And he said, why? The browser's commoditized. And I had to kind of try and explain to him, like a pioneer might explain to like a rich guy back east in New York in like the 1800s, like, There are no roads out here. The things you take for granted do not exist yet. We haven't figured out how a back button works. We haven't figured out how a URL bar works. We have not figured out the most basic things. So you're talking about commoditization. I seek commoditization. I would love commoditization. I want to see the commoditization of the web in virtual reality. So no matter what kind of developer you are, no matter what your aspirations are, you can integrate the web into your application. You can build entire economies and entire companies and entire services on top of the web. I think that's what we should all collectively seek. Once we've got that, we can all go make a bunch of startups. We can all go do whatever it is we want to do on top of it. But right now, the web is not there. And so if it's not there, there's a high degree of risk, I think, in it getting left behind. Maybe the way, well, even maybe worse than it was left behind in mobile, because there are some more inherent challenges in VR. Let's commoditize the web for VR. So in terms of how we do that, well, there's kind of a lot of people have been thinking for a long time about what the metaverse is. You'll see these amazing, mind-blowing, very comprehensive thought exercises and products, and some open source, some closed, into what a metaverse might look like. And so, for example, High Fidelity, Second Life, very notably. There's a couple really neat ones out there. Those are kind of attempts, I think, to start from scratch for the most part, which is totally legitimate. It's a really good thought exercise. The approach that being at Mozilla and being a platform guy who is a steward of the web we have, the approach that we want to take is kind of taking this oil tanker and kind of turning it by a couple of degrees at a time, pointing it towards VR. So I want to try to think about incremental steps that we can take to get us towards that end goal, while more nimble, smaller teams innovate on the UX side and innovate on the VR side without the encumbrances of the web. So the metaphor I use is if the web's like an oil tanker, you kind of want a bunch of speedboats in front of it who are doing the mine sweeping and are doing kind of finding the good paths for us to follow. So Janus VR is a really neat project out there. It's webby, it's very webby, but it's not quite the web. But that's good because James, who's running it, isn't encumbered by all the encumbrances of the web. So he can do neat stuff. He can do links as portals, for example. Another good example is Darknet, which is a really mind-blowing VR experience. And Darknet is like a rendering of what the web might be someday, maybe in 10 years. And so he's at the frontier of creativity while we're kind of back trying to enable the base stuff. So I think it's a really healthy relationship we're seeing right now. I think that's how the web's going to move forward. So my talk will be on kind of the, not links as portals, but more the next logical steps in the process. So first is VR native browsing. I mentioned with mozvr.com, you can't go anywhere from anywhere. We've got to fix that. So you should be able to type in a URL with your headset on. You should be able to go back with your headset on. If you want to log into something, you should be able to type it in to that login field. Just the fundamentals of browsing, you should be able to do them with your headset on without any external dependencies. Second, backwards compatibility. If you're going to go anywhere from anywhere, it stands to reason that most of anywhere is classic sites. You know, we've got billions of mobile sites and desktop sites, and we're not going to stop making them either. No matter how successful VR is, like, there's still going to be people buying new phones in 5 years. I've got a standing bet with a coworker that Apple will still be selling OS X desktops in now 9 years. And I don't know how I feel about that, but it seems like a reasonable bet. And these will probably be 2D. So we're going to continue to make 2D content. We have to have a way to interact with it and access it from VR. And then obviously full VR sites, because conversely, a web full of 2D planes would suck, and it would be a catastrophic failure of imagination. And I think it would limit the impact that the web can have in virtual reality if we don't go beyond just 2D planes. So how can we make really great full VR sites? And just to throw in a bit of for us to think about, the web has never tried to compete or has never competed very successfully toe-to-toe with bleeding edge native. I tried to build an operating system on top of the web. I know how hard it is to compete with a really great native experience. It's very difficult. So I think we have to be smart here and think about what is the web going to be good at? Maybe we leave it to John Carmack and the guys to enable the bleeding edge AAA Call of Duties of VR, and we figure out what the web can be uniquely good at, and then find out what is the good enough performance level of the web in virtual reality. So let's figure out where we want the web to compete, and then figure out what's good enough for that. Again, it does not have to be bleeding edge. It doesn't have to be the top tier. It doesn't have to be 120 hertz, for example. Let's figure out what a good level is for full VR sites. And then lastly, just again, for the sake of commoditization, more device support, more embeddability, and better performance, just continually making it better. There's a lot of low-hanging fruit we can do here. I know that Brandon and my colleague Vlad are both talking about fast pass in the browser for latency. Right now, there's a couple things we do in the browser that don't need to be done for VR necessarily that would actually really help with latency times. I think Vlad said we're at 60 milliseconds for latency. We want to get down to 20, so we have to make that better, right? And then embeddability. So like I said before, anyone who wants to make a VR app can use the web. And device support, more HMDs. Like we should be HMD agnostic. We want it to work everywhere. And also input devices. We don't even know what the default for CV1 will be, so we have to hedge our bets and make sure we support a wide range of devices. And luckily, web APIs in the last couple of years, in part thanks to Firefox OS and other efforts, have gotten much more robust. So we just released a web API, I think, for on Firefox, I think for voice control, or it's coming very soon. So we got some pretty cool stuff for WebRTC, for example, or camera control, or local storage, or battery life. Like the web is better now than it's ever been at actually talking to hardware. So we want to get that information out there and continue to make it more robust for virtual realities, maybe depth sensors, things like that. Now, this is the part of my presentation where I have to remember, I have to start dancing between slide decks. Yeah, here we go. These are just a bunch of, I do lots of experimentation, lots of experiments. This stuff will all be online at a link I'll share later. First thing is backwards compatibility. That seems to be one of the first things we need to figure out. So we've been playing with different models. What we kind of want to do tonight, and in a blog post we'll send up on Tuesday, is begin a conversation in the community about what's going to make sense and what's going to empower developers. So for backwards compatibility, like the default should just be render the site faithfully, maybe apply it to a plane, have like a virtual viewport inside a cropped viewport, just like we have on mobile, so that the virtual viewport can be pinched and zoomed, because legibility kind of sucks in VR, so you're actually going to want to lean into content or make it larger. It seems to me to make sense to also curve it around the user, so we've been playing around with models where there's actually some curvature around the user here. I think we're going to have to figure out just how much content we can pack into it. So for example, this is a Medium article. That's really hard to read in a DK2 with its resolution. It seems like it's going to be quite a few years before resolution really gets good enough in these headsets to make looking at text really palatable, but we should still be able to do it. So what we're playing around with is a virtual viewport inside a cropped viewport, curved surface approximately 50 centimeters away from the user. That's just the default. So a web author doesn't have to do anything whatsoever to their existing site, and they'll get this sort of behavior. And there's some more details there we can get into about how it would actually work, and we'll get into in a second. So we've just been doing legibility tests, like, okay, well, Wikipedia, how the heck would this actually work? These links would all have to work, by the way, so we'll need some sort of cursor system. Clicking on links would work, mouse events should work, scrolling should work. Like the fundamentals of web interaction have to be recreated. The job, I think, is not unlike what the Mobile Safari team had to do in 2005, or whatever the hell they were doing it, which is to say, to take the content of one medium and crunch it down to a different form factor, and then come up with adaptive interactions and display techniques to make it palatable. So what is the pinch to zoom of VR? You know, what is that going to be? And so again, we're just doing lots of little copy and paste exercises internally, trying to figure out what the information density can be and what might be promising techniques for VR web design. This is literally just the Wikipedia page, for example. And this, to give you a sense of scale, like me looking up here is now me craning my neck up to try and read a website. Like that's not necessarily that pleasant, but maybe it works better if it's smaller, or if we can actually shrink the content down by doing those pinch to zoom actions. But again, this is like the default backwards compatibility mode. Then there's full VR site. So a full VR site would be a site that has complete control of everything the user sees, hears, and does. So those Moz VR sites I showed you, that's full VR. The viewport expands to take over the full 360-degree space. You're not cropped to anything. You are now in a world. You know, that is, I think, what we want a VR website to be. And hopefully we'll see a lot of those created. We have to think about what the enablers for those will be. And then between those two extremes, I think there's a really, really interesting place, which is, if I'm Wikipedia, I'm not going to convert the gazillions of individual pages or the gazillions of individual style sheets I have to be these wonderful full VR worlds, but I also don't want to be like this. This is kind of, a couple slides back is kind of crappy, especially this one, you know? So how can we enable developers to do what they like web developers to do, what is a best practice anyways, which is to use responsive design techniques to actually adapt to the form factor? We're trying to find these neat little judo moves and propose them to the community for responsive VR design. So like one, for example, is, well, I mean, I showed you this Wikipedia process, but if I know that I'm within VR, and if I know I'm being presented on this kind of curved surface with kind of rectangular orientation, perhaps I switch to CSS columns and actually begin to display content in kind of a left-right orientation. For example, perhaps I actually increase the text size, which isn't shown here, but text size being low, maybe I beef it up a little bit. One that really, really excites me is all this stuff here. This is like the equivalent of the status bar in iOS or Android. That's user agent space. But like iOS and Android, perhaps we can enable developers to actually tell the user agent what they want to put there. So maybe there's a CSS tag that enables the developer to say, all right, viewport background is this, and they can actually drop in an equirectangular image, for example, and then maybe they can make their content transparent. So this is a really, as a visual designer, this really pains me to be showing you really early crappy work like this, but maybe it's like this, where imagine that I've got that curved viewport is still present, but it's now the background of that curved viewport has now been made transparent, and we've also used a CSS property to actually drop a background image into the background there. And it says Tahrir Square, and it shows Stonehenge. Like I said, it's really embarrassingly work in progress. Our CTO is like, I have to point out one thing. I'm like, I know. But I think you can get a lot of mileage out of transparent content on a curved surface with something in the background, like a ton of mileage. In fact, the reason I'm confident of this is that's precisely how I've been doing our internal. One second. I need to make this less or more legible. See what I did there? This is how I've internally been doing our mockups. So MozVR, the way I actually built these was in Illustrator. Apply to all, ignore. In Illustrator, what I've been doing is I've been making these canvases that are 360 centimeters wide and 90 centimeters tall. And then I put them onto a cylinder surface, which is 50 centimeters radius, and I kind of wrap them around the user. And so I get to work in 2D, and I know exactly, because this is all based on centimeters, exactly where the center is and where right behind me will be on the respective edges. And then I just make the background transparent. I drop an rectangular image, and you get a ton of mileage out of this, especially once you start making multiple layers. And you say, right, well, these bookmarks, let's drop them back 5 centimeters, and let's make this thing 5 centimeters forward. Again, we can do that with CSS 3D transitions. And in VR, that subtle 5 centimeter separation becomes as obvious as like a drop shadow in 2D composition. It's incredibly, incredibly powerful. So there's just one example of how, with the ability to detect the context, we can actually customize our style sheets to optimize for VR. I think what we have to do first before we can get there is kind of agree as a community and begin to play around with what the default viewport for classic content is going to be. The other thing we have to figure out is really determining what is a classic site and what is a full VR site. Imagine if on mobile, everyone was making mobile websites, but to actually kick into the mobile web rendering mode, you actually had to hit a button manually. It would really suck. I mean, you want to be served the mobile version, the optimized version for the device automatically. And right now, you're not on the web. User agents, if you click on a link, that's not a MozVR link, but if you click on a link, you're going to be thrown out of VR mode, and you're going to be back in desktop mode. We need to find a way to have the user agent understand, and for the developer to declare what kind of site they are, so that we can make browsing as seamless as possible, so developers can optimize their views. It's subtle, but it's really important to the seamless web browsing, which is what we want to achieve. So on the blog post, we'll send it on Tuesday. There'll be some proposals for that. Brandon's got some. It's really early conversation. There's some really smart people inside Google and Mozilla and in the web dev community who need to have a conversation about this, who really know this stuff. But we're talking about like events or meta tags or even protocols like VR protocol. We'll figure out what it is. How many for time, Tony? About 5? OK, great. You know what? I'll jump to transitions then. Because transitions to me are really important for, OK, transitions on the classic web are just blink, blink. You know, like page pops in, page pops out. It's pretty jarring. On VR, that could be really jarring. And moreover, I think it would be an enormous creative lost opportunity. So let's start playing around with transitions, both in the user agent, like doing in-stream transitions. Again, these are going to be really heavy-handed because this is me just messing about on the weekends. But it could be a lot of fun actually playing around with how we actually move users between sites. So on MozVR, you saw that kind of black-white wipe. The user agents, I think, will have a ton of freedom to actually experiment with this. And I think also we can let developers experiment with this. So I think the Google Chrome team recently, as part of the material push, have put forth a proposal to actually enable developers to determine the transition as you move between individual URLs. That's pretty interesting when you apply it to VR. So can a developer determine what the experience you see is when you move between two URLs? Is it like leaping between two worlds? Is it like stepping through a doorway? Is it just a quick blink? Maybe we can empower developers to actually have control of that as well. It'd be pretty interesting. And then full VR browsing experience. We're really early on this stuff. We're just trying to figure out how might this work exactly. What kind of things would you want to have? How will text entry work? Text entry is going to be a really tough one. We have to figure out some kind of clever solutions. Maybe web VR design for the first little bit is more like Yahoo. It's kind of like if you've seen a lot of typically Chinese web design, it's a ton of information density, a ton of links. And maybe there's not so much URL entry. Maybe we kind of have more of a directory approach to navigation. That might be interesting. We're trying to work out the basic conventions and like history representation, multitasking, how do we do that? These are, again, by the way, all these mockups are using that technique I mentioned before, which is to say transparencies mapped onto a cylinder with something in the background. So trying to figure out how full VR browsing is going to work and then and what it's going to have. We're really going to try and hack for the next 6 months pretty intensely on this in a very public and open way. So I wanted to show you code today. I couldn't, which is why I'm showing you 4 different piles of slides and presentations. But you'll see a lot more from us in the next couple months on this. Hacking in the open and encouraging other people to kind of kick around ideas with us in terms of interaction and then development methodologies. And then I can say I'll skip over additional platforms, additional input devices, et cetera, because I kind of want to wrap up by talking about something that, to me, it's kind of a very vaguely formed idea. It's not even tweetable, maybe, but I'll float it here. The web on mobile, browsing on mobile, really suffered because you don't need a frame within a frame. The browser's a frame, the operating system's a frame. There's not enough room on the screen to actually have both. So it was very awkward to have a browser within the smartphone. I mean, the smartphone, the operating system of the smartphone really took over the jobs we hired the web to do in a big way. So general purpose browsing on mobile is not really that interesting. And if you look at the designs, the interaction design, and if you look at the visual design of competing mobile browsers, like there's very little difference between them. Like Firefox Rounder, which is a great mobile browser, it's distinguished by a swoop in the upper right-hand corner. It's a lovely swoop, but there's not a lot of creative freedom there to play. So what really excites me about VR, and what I think is maybe subtle, is the amount of variance, the massive amount of creative freedom that user agents are going to have to differentiate one another. So you can imagine what a power user browser from like a neuromancer snow crash addict might actually look like, and how radically it might actually be from, like, let's say a browser made for like let's say a child, a safe browser. You can imagine browsers competing based on maybe anthropomorphization of security threats. So a security threat could actually manifest itself as flies buzzing around you, or your trackers could be cans dragging behind you. One like kind of scary consequence of WebVR will be when guys like the 4chan crew get their hand on it, and the kind of gnarly, crazy, scary shit they could render right in front of you right here. So maybe user agents will compete based on security. So one can imagine that one user agent might actually, as a feature, roll out like a geometry occlusion device, which is to say that you as a user can set a range within which all geometry of the rendered scene is occluded. So nothing can be put right here. And all volume is automatically muted and slowly ramped up when you get into a site. I think that there's going to be a massive amount of competitive potential between user agents and WebVR in a way there never was in browsing. And I think if we do a good enough job of making really compelling web content, that people will want to use these user agents to actually browse the web. So I'm very, 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 very excited for where the web's going to go in the next couple of years. There's more I can say, but there'll be a blog post out on Tuesday about this stuff, along with a newly relaunched mozvr.com. We're going to relaunch it to make it really great as a developer resource for anyone who wants to make these kind of websites. So a lot of content there, a lot of blog posts, a lot of tutorials, a lot more code samples to help developers just start making stuff. And then lastly, what I'll say is Tony mentioned that nightly builds of Firefox are going to get a WebVR support. They actually have it. You just need a couple extra steps, and we're going to, on Tuesday, outline what those steps are. But it's really good news, because it means that WebVR is now in our main releases, and from there, it spreads out into Firefox proper to lots and lots and lots of people, so that's really a good thing. So thank you very much. I think that, holy crap, I almost nailed it, right, in terms of time. Yes, all right. So thanks so much for having us, too. And by the way, I'm really lazy, and I love it when people have meetups that are 20 meters from the front door of my office. So Google can keep posting them here. Yeah, thank you very much. Thank you.
Thank you. Thank you. All right, so we've got a quick break. In fact, speaking of keeping it close, we actually reserved this room for all of our meetups this year. So, yes. That is except the one in March. So the one in March will be at Autodesk, just not too much further. So we're going to take a quick break. Let's be back here. We have about 4 minutes of lightning talks at 7:10. So we're in session again in 15 minutes. So there's some desserts and wine and cocktails out there. All right, guys. While we're filing back in, hopefully you had some of the dessert. I think we ran out. I want to start off with a quick lightning talk before we start the next part of the program. And just a quick reminder that the bus will be leaving downstairs. You don't have to, like, as soon as the event is over, there will be a bus downstairs that will take you to the Metreon for the VR Expo, the Upload VR Expo. Use SFHTML5 as your coupon code to get in there. I think at that point it will be $15. So a quick lightning talk for 4 minutes by Isaac, one of our last year's WebGL speakers. Isaac, take it away.
Hello. So for those of you who don't know me, I'm Isaac, and I make things in WebGL. I'm going to start the timer real quick so I don't go over time. And so, yeah, this is my site. You guys should play with it. It's great. There's no CSS 3D because that's a lie. It's only WebGL, including these things. Oh my gosh, you don't even need HTML for those either. And basically what I want to talk to you guys about today is something called synesthesia, which is a very difficult word for me to say. And my writing teacher always told me that you should never start a talk with a definition of a word, so I'm going to do that. Synesthesia from Wikipedia means a neurological phenomenon in which stimulation of one sensory or cognitive pathway leads to the automatic, involuntary experiences in a second sensory or cognitive pathway. So just keep that in mind when we're talking about VR. And I'm going to show you guys something that I've been working on. And since I can't really show you guys all the Oculus up here, we're running it over by our booth outside. So check that out, definitely. But basically, when I think about VR, I try to think about, like, how do we create a synesthetic experience? How do we do something where by getting visual input, you begin to experience things that are not just visual stimuli? You get this a bit in some ways with movies, because like when you see like a big mountain and you have a secondary cognitive stimulation of like saying like, oh my gosh, that mountain is huge, I'm so small, you start getting a bit of this synesthesia. But as you all know, with VR, you get the opportunity to do that a lot more. So the project that I've been working on is this thing here. It's way, 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 way cooler in VR. But it's still pretty cool here. So basically all it is a bunch of fancy WebGL things. But the thing that I really, really like about this is the fact that it actually feels like something. Usually when I'm showing people the VR experience, I ask them not like, what do you see? Are the colors sparkly? You know, like, do you like the color scheme? I say, what does this material feel like? And people actually respond with sensory, like, descriptions of the object. It isn't necessarily like, oh, it feels like I'm touching a metallic paintball. It more is like, it feels like velvet, or it feels like a waterbed. And we have the opportunity to do that with VR, which is what's really exciting. We don't necessarily need to make something that is specifically trying to tell you something. We get to make things that show you something. And my writing teacher really, really liked that, so hopefully it'll even out. If you guys have the opportunity today, you should go outside and try it out there. There's a lot of people and only one Oculus, so it might be a bit difficult. But I think that the thing that I would like to say for this very, very, very short talk is that when you are designing an experience, think about how you can make the user feel. Don't necessarily think about how you can make the user accomplish the task that they need to accomplish. That is something that we're going to figure out. And after hearing a few talks, I'm much more certain that we are going to figure that out because we have so many brilliant minds working on that. Something that we haven't figured out yet is how we're going to get people to like really like believe in VR. And that is something that we need much more than we need VR to be useful. I'm sure people will probably disagree with me on that, but I'm going to go with it anyway. So just, yeah, that. Think about how your user will feel. Think about the different senses that they will be able to like sense. And think about how the fact that like everybody, when they talk about VR, they're like, I want to feel like a superhuman. But being able to use our own human body in the way that it is meant to be used is superhuman enough. When you hear people say, like, you can show the Oculus to somebody who's 80 and to somebody who's 5 and they get it, that is us being able to use the superhuman power of literally just being human. So yeah, come play with this ball. And also it's online if you have a Leap at Kabibo/paintball. Thank you, guys.
All right. I have 15 seconds. Hi, I'm Oswald. Just to let you know, there will be a 2-day course next month on AngularJS and Node.js with Superstar, Adam, not Corolla, Crabtree. If you're interested, come talk to me. And by the way, if you know anything about Glass 2, I would love to talk to you. Thank you.
All right, thanks, Oswald. Okay, we're turning it over to our next set of speakers. Wow. Next up, Brandon from Google will tell you all about Inside Web VR.
Yeah. Okay. So we've already heard from Tony and Josh about design patterns and whatnot. Very fluffy, feely, good things about VR's future, and we saw the cool little paintball demo. And now I'm going to be the downer that just talks about really technical stuff. And if you want somebody to blame, last time I was at one of these meetups, Shannon Norrell, who I think is here somewhere, said very specifically, I want to see code. I want to see what makes this work. And so, Shannon, here you go. So, today we're going to talk about what makes WebVR tick, aka all the gory details that 3JS tries to protect you from, but you should probably know anyways. By way of brief introduction, my name is Brandon Jones. I work on the Chrome team. My day job is making WebGL better, more stable, faster. But WebVR is kind of my 20% project. I'm sure a lot of you have heard, that it's a thing we do at Google. And it's been really inspiring to work with people like Josh and Vlad to bring this up across multiple browsers. So everything that you see here should generally work. It should generally work across both browsers. Now, because this is going to be a massive data dump, yes, these slides are online. You can go see them right now if you want. I'll leave this up for just a few more seconds. Don't sit and try to scribble like crazy and you don't feel like you have to take a picture of every single slide because there's a lot of data to go over here. In fact, there's about 30 minutes worth of data that I have to cover in about 20 minutes. So I'm going to kind of talk fast. So, at the very outset of things, we need to be able to have a way of getting the devices that are connected to your system. Now, this may be an Oculus Rift. This may be just your phone that we're treating as a VR device. This may be some future device that we don't know about. In all cases, you're going to call navigator.getVRDevices, and this will return a HTML5 promise. Now, if you haven't used promises, then sorry, but I'm not going to cover them here. Go read up on it. But effectively, it's an asynchronous event that will come back at some point, in this case, denoted by the then operation, which we'll call this thing. Now, this is getting cut off on that screen, isn't it? Is there any way that we can poke this down just a little bit? I'll keep talking while we go. In any case, you're going to get back a list of devices. And we need to iterate over these and find out what the capabilities that we have available to us are. Now, a single device in this array is not equal to a single piece of hardware. We may have 2 or 3 different devices that all come back for a single Oculus Rift. And the devices actually represent a particular capability of that hardware. So in this case, we have an HMD VR device, which is all about, thank you, which is all about the optics of the system, the field of view, the IPD, everything that you need to know to create a correct image for the hardware that you're looking at. We also have the positional sensor VR device, which, as you might imagine, gives us information about the position, orientation, acceleration, all that good stuff. Now, how do we associate these two together? Because you might have actually multiple VR devices hooked into a computer. That's kind of insane right now, but it might happen. Is you look at the hardware unit ID, and this will associate those two devices together. Every device that represents a capability of a single piece of hardware will share a hardware unit ID. And so you can correlate those two together, figure out which device you want to use, and now we're off to the races. So, getting into the more interesting bits, a VR application at that point is simply a scene that you are rendering twice in a certain way that allows it to be picked up as the user's eyeballs as a 3D volumetric scene. If you're not doing any of the distortion to it, it looks exactly like this. This is a single WebGL canvas. We just render the scene twice using viewports to kind of wall off each eye from each other. And in order to do that correctly, and it's very important that we get this correct, because if you don't get the field of view or the IPD or anything else correct, it's going to look weird and it's going to make your user sick, and nobody likes barfing users. So we're going to go over some of the basic math to how to get this right. And once again, I'm going to skim over this pretty quickly, but these are online if you need to reference it later. First thing that we need to do is make sure that we get the correct canvas size. So now you would think my Oculus Rift has a 1080p screen, therefore I need to create a 1080p WebGL canvas, and life is good, right? No, not really. Because what we're going to do is we're going to apply a distortion to the image after we've rendered it. And that's going to cause the very center point of the image to kind of bulge out, and it's actually going to lose resolution in doing so. So by using this stuff right here, we can actually calculate an image that's the right size. It's going to be bigger than the actual physical screen size, so that when that distortion is applied, what you see at the very center of your eyeball is a 1-to-1 ratio with the pixels on the screen. So the next thing, and this is using the Git recommended iRender rect, because we're very uncreative with our naming. And you'll do it once for each eyeball, and what this gives you, going back to this page, is effectively the rectangle that describes a single eyeball in pixels on your canvas. You can also use this for GL viewport, which is shown on the bottom bit right here. Sorry, like I said, I'm going fast. Nope. Go away. Wait, sorry, got to get my bar to go away here. Wow, that really doesn't want to do that, does it? Sorry, one moment. There. Okay, so this is a whole lot of math that represents how to get the correct projection matrix for your eye. Once again, this is going to be the matrix that everything gets passed through so that it is projected the correct way onto the canvas. It is very important that you get this right. The field of view, which is just a frustum, it's described in terms of degrees. It's going out from a particular eye, and it's kind of skewed. It actually points out from your head in, at an angle. You can get that using the Get Recommended Eye Field of View. And then you do that to it, and you get a correct projection matrix. Moving on. So now that we've got our projection matrix, those of you who are familiar with 3D already know that you typically have a projection matrix and a model view matrix, and the two of these come together to give you the correct sense of 3D in a scene. So in order to get the view matrix, now we need to start bringing in some information about where your head is actually positioned in space. Up until this point, everything has been based on the physical parameters of the device, how big the lenses are, how far away they are from the screen, everything like that. Now we're starting to talk about getting information from where you're looking. One more piece of information that we need to get from the device, though, about like the physical sense of the device, is get eye translation. Now you call this once per eye, and it tells you how far from the center point of the user's head the center point of their eyeball is. This is, once again, very important to get right, because if you fudge this factor at all, your user will either feel like a giant or a midget in whatever 3D space that you give them. And same goes for the position. So we'll talk about where the state comes from in just a moment, but the position is the actual position of your head. So if you're using an Oculus Rift DK2, not all devices will have this, but some do. You actually get tracking of where your head is offset in the world. And that comes through into this position. It has to be right, or else the user will feel like the world is just too small or too big. And it is absolutely critical that you make sure that this value and your eye offset are in sync and that they're scaled appropriately to the world. So for example, in the Quake 3 demo that I have, which I'll try and bring up in a little bit if I have time, in Quake 3, a meter is equal to 32 units of game world. So if you're looking at the game world, you're looking at the geometry, 32 of those units will be approximately 1 meter in the game world. The eye translation that we get and the position are both given in meters. And so in order to make those positions match up with the positions of the world in Quake, we have to scale both of these numbers by 32. And that gives you something that feels correct to the user. If you don't do that, then they just feel tiny or huge. And it's very disorienting. So now this isn't like the exact math that you would have to do for your particular app in order to get the right view matrix. It's just pseudocode, but you're going to have to do something that looks approximately like this. And I want to point out one thing really quick. This is in red for a reason. Brief tangent. Quaternions are not Euler angles with an extra W component. I see this on mailing lists a lot. And it's unfortunate that it almost works. If you try this, you'll get something that looks, you can try it and you'll go, oh yeah, that looks right. And then somebody else is going to pick it up and it's going to go, ugh! And it's just going to be weird. So please, when you're doing your math like this, this orientation is coming back as a quaternion. Learn how that math works, convert it to matrices, do whatever you need to do. Do not treat it as XYZ rotations. I promise you that will end in tears. So, moving on. Now that we've done all that, we can actually get to drawing the scene. So I mentioned earlier we had that state object. This is where that comes from. It's the positional sensor now instead of the HMD device. You call getState on that, and that gives you a nice little bundle of what your orientation is, what your offset in the world is, and what acceleration you have. Probably won't use the acceleration too much, but it is there on devices like the Oculus Rift. So the next thing that you have to do is effectively just render the scene twice, which we can see here. You want to set up your viewport for the left eye, the matrices for the left eye, draw the scene once. Set up the viewport for the right eye, set up the matrices for the right eye, draw the scene once. And that's how you get VR. Except that's not what you actually want to do. It's a lie. It will get the job done, but I'll talk about why it's the bad way to get it done in just a moment. Now, the final thing that you need to do is on devices like this, if you're using cardboard, you're done. I mean, that's more or less everything that you need to do. But if you're using a device like this actually has its own screen in it. And your browser is probably not showing up on this screen all the time because that's a really hard way to use your browser. You can only see it halfway at a time. And you want to project the image onto that hardware. So we do that by using this extension to the already existing full screen API called request full screen, and you pass in this new optional array or object full of attributes, pass in the HMD device as your VR display, and that tells the browser, I need to display this image on that headset. Thank you. And it comes out looking like this. This was the original image. This is what you rendered. And then the browser does magic, and it really is kind of magic sometimes. And it comes out looking like this on the HMD. So the benefits of doing that are the browser knows how to automatically correct for the distortion of your headset, whether that be an Oculus Rift or Google Cardboard or anything else that's going to come up. The idea is that we will be able to do that for you. We'll be able to correct things like chromatic aberration that come out from the lenses. We can do techniques like time warp, which is currently working on all the Oculus implementations of Chrome, which, as you're moving your head around, will do a last-second pulling of the of where the device is looking and shift the image that you rendered ever so slightly so that it more closely matches up with where the user's head is pointing. This makes a massive difference in the feeling of smoothness. We can also invoke things like direct to HMD. If you're familiar with Oculus, that's basically a mode of sending the image directly to your headset rather than treating it as a secondary monitor. And on some devices, we're still working on getting this ubiquitous. We're able to actually start throttling the request animation frame at the correct frame rate. This device renders at 75 hertz. Your computer monitor doesn't, I can guarantee you. And so in order to make sure that that comes out as not jittery, we have to render at 75 hertz as well. This API allows us to switch modes in the browser so that we start running at that rate. So now, I've talked a lot about math. This is the 3JS version of everything that we just talked about. And that's why you want to use 3JS. It really does everything for you. It's very, very simplistic. You'll create a VR controls based off of your camera that automatically tracks everything you do with your head. You create a VR effect that does all of the pushing to full screen and everything like that. And you just kind of render the rest of your scene as you would a normal 3JS app. It's really, really nice, and it gets you going really fast. And if you're just starting on either WebGL or WebVR, I highly recommend going this route first. One small caveat. I don't know if you guys have heard the joke about C++ being, if you want to build an octopus in C++, you staple legs onto a dog. Well, VR Effect is currently very much stapled onto the side of the 3JS dog. That's not to say it doesn't work. It's just not designed, well, 3JS specifically has not thus far been designed in a way that it treats VR as a first-class citizen. The render pipeline is not optimized for that. In most cases, it is good enough. But there's a way to go. So don't expect complete magic. You might need to do some optimization. Just fair warning. So given that, a couple of tips for optimizing your VR scene if and when you get to that point. And there's some of this that's available in a really awesome slide that I found on Twitter. I don't even remember who did it, sorry. But it's linked in here, so if you're looking up the slide deck, you'll be able to find it. It goes into a little bit more technical details, but a couple of things to consider. In VR, your fill rate is about the same as a normal app. Like, we're not doubling the amount of fill rate that you're using to present a scene. So if you can present a scene on your screen normally and it runs at a good frame rate, then the same fill rate for your GPU will probably work well for VR. What you're doubling is the amount of vertex processing that you're doing. So if you have heavy-duty vertex shaders, this is going to hit VR harder than it will anyone else, or harder than it will a normal app. But even so, fill rate can be something that is, it hits the performance hard, so be willing to reduce the canvas resolution. John Carmack said somewhere, reducing the canvas resolution in VR is almost always the right choice for performance because it's not going to look that terrible, especially on the current devices. If you have things in your scene that are not view dependent, like shadow maps, do not render them twice. Shadow maps only need to be generated once per light. This is something that I think 3JS isn't doing a good job of right now. And then finally, the pattern of set up a scene, draw one eye, set up a scene, draw the other eye is maybe not necessarily the right thing to do in VR. What you may want to do is iterate through the entire scene, setting up the viewport, drawing an object, setting up the viewport, drawing the object again to reduce the amount of state changes. This will depend heavily on the type of content that you're rendering. And so you should test it out, but it can be a useful methodology to go through. I'm going to go really quick through the last few slides because we're almost out of time here. In Chrome, the work on WebVR is still very much in progress. I think it's going to be a long time before we can say, confidently it's done. Latency is still way too high. The time warp that we have implemented helps a lot, but it's not enough. We want to do techniques like asynchronous time warp and get rid of some of the UI bits that don't really work with VR. It's an ongoing process, and it's one that we hope to continue making great strides on in the future. I'm actually not going to talk too much about this slide because and then, so Oculus Rift, by the way, there's a couple of issues that you might run into if you're trying to use it with Chrome or Firefox. You can refer to this. It's got some tricks to help you get going. Cardboard, on the other hand, the way to use that is you go get one from the nice people at the booth. There should be one for everybody here. You use it, you develop for it, and life is good. It actually works really spectacularly well for what it is. So that's everything that I have. Hopefully I haven't completely bored the audience here. One last thing that Tony wants me to show, so might as well. So this is the Chrome WebVR enabled build that you can get from one of the sites that we'll have linked on the Meetup page afterwards. And you can see that I've got a VR button here. Click on that. This looks very similar to what Josh was showing. And this is basically just a scene from Quake 3 that is rendered in the browser in VR. Not super complex by today's standard, but it runs really well. It's a very compelling thing when you're actually looking through this headset. The scale is right, the frame rates are good, and it just feels really good. So, this is what's capable right now today with the VR. This even works on mobile. Works really well, actually. And, I think we can only go up from here. So. Thank you, everyone, and I believe now we're going to be turning it over to Leap Motion.
All right, thank you, Brandon. That was great. Thank you for staying on time as well. All right, while we're switching laptops, just a quick repeat announcement about the next event. So our next SFHTML5 event will be on February 18th. It will be here in this office. It's already on the site, so you can sign up already tonight, and then it will be going public this weekend. So after this event, if you haven't heard yet, there will be buses that will take you for free to the Metreon, where there is the big VR expo that will be running. It's already started, and it will be running till 1 a.m. So we'll take you there. There won't be rides back, and it will take about 50 people at a time. The bus will just make loops until everyone that wants to go is there, and then we'll bail. So let's see. Okay, we're already live. Great. Good. So the next talk from David Holtz from Leap Motion.
Hello. Can everyone hear me? All right. Great. Thank you. Thank you. Hi. So my name is David Holtz. I'm the co-founder and CTO of a company called Leap Motion. We make really cool cutting-edge hand tracking devices, and I'll try to show you guys a quick demo of that in a few minutes. My talk is a little bit more general than that, though. It's about just the general future of wearable displays and inputs. I'm in a kind of unique position where right now most people in this space try to talk to each other as little as possible. Not you guys, of course, but the guys who are trying to build these displays, build these input devices. Everyone's pretty closed. But everyone talks to us. Because right now there's this thing right now, everyone's starting to realize that if virtual reality is going to be like actual reality, we're going to end up using our hands. And we thought that was obvious at the onset, but it's kind of dawning on everyone now. So yeah, we're going to talk a little bit about that. And but what we find is when people come to us, they tend to come to us with like very different visions of what's going to happen over the next few years. And of course, because we're like a real company trying to like make a business in the midst of this, we're trying to figure out, okay, like what is actually going to happen. And so this is sort of pieced together a little bit. And I won't be able to name any names or say anything really like that I shouldn't say, but I can say some things that should be pretty interesting and hopefully stuff that people haven't heard before. All right, so I'm going to kind of talk about like the next 5 years worth with a quick disclaimer saying that if I was going to tell you exactly what was going to happen, it would probably sound pretty crazy. So if I don't sound a little bit crazy, there's no chance I'm going to be right about anything. It's Arthur C. Clarke. Cool. So what I do is I kind of I'm going to break up sort of all of these head-mounted displays into sort of 3 generations, which is something that people don't usually do, and you can quote me, but most people don't do this because no one really knows enough to do it. So these kind of have these generation 1 head-mount displays, which we kind of call what everybody is using right now. And they're tethered, they're large, they're multi-device products, which means you need like a webcam, you need like a PC, you need like a head-mounted display. It's not just one thing you can hold in your hand and say this is a product, like this is a singular product. There's a lot of advantage to this. Any computing device can be plugged into these things, so any computing device can be one of these types of head-mounted displays. But it's very much limited right now by basically 2010s era smartphone technology, device I/O, and like 80s era optics. There's a really interesting price wildcard we're seeing, which is that like people could build these things and sell them for like $99, like just almost nothing, like because and that's the sort of stuff that people do all the time in the tablet market. So there's definitely something that is interesting about these, but they're going to come pretty soon, and they're pretty much going to be the least that we can ever expect, and that's this year, next year, is sort of the year of Gen 1. I'm going to talk a little bit about Gen 1 sensors. So right now, as you guys know, legacy AR devices still exist. We got wheels, joystick, keyboards, mice, et cetera. We're starting to get these handheld controllers like the Razer guys and the PlayStation Move, and those stuff are getting increasingly refined, and there's a lot that can be done there. And then right now, the sort of touchless motion trackers are undergoing rapid evolution. And now, by touchless motion trackers, I'll call that Kinects, us, the PlayStation Eye, the Oculus Head Tracker. Those are all sort of touchless things that track stuff. All this stuff is pretty much made with off-the-shelf parts, but we're pretty much limited in every respect: bandwidth, cost, power, size, everything. Now I'm going to take a quick second, in case somebody has no idea what we do at Leap. We make this thing, and it's a Leap motion controller. We recently came out with a mount, and you can put that in, slide it on an Oculus, and basically we have this field of view. It's basically a camera. And everything inside that 135-degree cone is tracked, and everything within that 100-degree cone is like what you see. So anything that you can see, you can then track. And we focus on hands right now. I'm going to do I usually spend a long time doing demos, but today we're not going to have as much time. But basically, you've got a camera. Oh, actually, you guys can't see. Hold on. All right. Yeah, you've got a camera. It's infrared. It's kind of high angle. Looks a little weird. But basically, and there's 2. So there's one over here and one over here. And that's all behind the glass, plastic. Basically, when I put a hand in here, we start tracking it. So what you can see here is basically a skeleton overlaid on top of my hands. And this is a V2 tracking, so we used to have a V1 tracking where sort of what you see is what you get. So if you see a finger, we track it. But we found people do lots of things with their hands like this, where basically it's completely sort of unreasonable in quotes, or like this, and they still want to be like, where are the fingers? And we have to tell them, because that's how it is, And it's really important because when you're a programmer, you don't want to have to be like constantly thinking about like, can I see it? Can I not see it? I want to just be like, take that pointer finger and I don't know. Anyway, so you can do really visceral physical interactions with this stuff. Here, I'm going to try to throw one more thing over here. We have a lot of cool demos, I think, out there in front of the tables. I'm not going to show you anything too crazy here. But basically, everything's in full 3D, and we're tracking the arms and hands and fingers very finely. And here we still have this sort of so I can kind of go like, here's this part of my finger, or this part of my finger, or this part of my finger, or I can do that, and stuff like that. Yeah, so that's really, really quick. I'm sorry, I love to show more demos, but I'm going to keep talking about the future for a second. From the current slide. Here we go. Cool. So we make motion sensors. That's a motion sensor. What does a motion sensor have to be for VR? Well, it's got to have a big field of view. You should, if you can see it in your field of view of the head-mount display, you hopefully can. Like if you put your hand where you can see it, hopefully you can use it. And it's got to have really high frame rate. ideally higher than the head-mounted display. It's got to be an integer multiple, which is interesting, but I can't really talk about that. You need scalable trackings so that you can always know where things are, even if you don't see them. And you need to have the lowest latency possible. And right now, you can get 120 frames a second, 8 millisecond video latency with a 4 millisecond latency for the hands, with like a roughly 140 by 120 degree field of view. And that's like $79. You can get it at like every Best Buy or something. So you guys can get that right now. It's cool. Lots of people are messing around with it. That's what we do. But of course, this was not actually meant for VR. This is just a cool 3D hand sensor for computing in general. But we're starting to make new ones now that are made for VR. And what might those look like? One of these prototypes we call Dragonfly. So it's kind of like Oculus has the Crystal Cove. So we kind of have our prototypes. And basically, each sensor is 3K resolution. So here's like the image of the thing you just saw. And then here's like an image of one of these things. So it's color, it's high resolution. And we've got infrared as well as color. So this is kind of weird. Most people aren't familiar with this. But your sensors usually are red, green, blue, red, green, blue. But it's red, green, blue, infrared, red, green, blue, infrared. So we have infrared pixels as well as color pixels. So basically, with the infrared pixels, we get an image like this. With the color pixels, we get an image like this. And we track the hands in infrared. And you pass the video through, so it feels like you're looking through a piece of glass instead of ski goggles. So that's really cool. And then you start to kind of when you give people that, they start to fade back and forth. So like maybe all your games you want to play at 20% transparency, so you can still see your environment. Or maybe you start to mix sort of augmented reality with actual reality type stuff. And there's a lot of really cool stuff there. And some people are really obsessed with it in the market on the back end, but some people are totally terrified of it. Probably for good reason. It's a big can of worms. When you start putting objects in these sorts of environments that are virtual, you start to be like, man, it looks weird. And you realize it's not lit right. And then you have to, shoot, I have to compute the lighting in the real environment. And it's a lot of stuff, but it's really cool. And so, yeah, it's basically much higher resolution, much higher speed, bigger field of view, more colors. That's the sort of sense of what you might see immediately after one of these types of devices that you could get at Best Buy right now. So now we're talking about sort of Generation 2 head-mounted displays. So they're untethered. They're still large form factors, but they're single devices. So like the Samsung Gear, you can actually hold something in your hands now and say, this is a VR device. And that's new and kind of crazy. We're still 2010s era smartphones. We're slightly newer optics, but still kind of not great optics. It's portable, and all cell phones can become them. And probably the biggest problem is still battery life, as you guys probably know. I think what we'll see... I'm going to say I think for everything. I think what we'll see is something like this, which is sort of like a cell phone with like an iPod headphone jack. And you could plug this into whatever you're wearing, and it gives you like 8 hours of battery life instead of 1. And you don't have to use it, but stuff like that makes sense. And we're probably going to start seeing those things more and more. The coolest thing about these is that I/O limitations start to disappear. So that means like right now I got to use USB 2. And that's really hard. Like that means I can do the Best Buy Leap Motion is 40 megabytes a second, and we're pushing that all the time. The Dragonfly you just I was just talking about is 400 megabytes a second. And of course, what if you want to do more than that? Well, you're out of luck. USB 3, that's it. But phones have this thing called MIPI, because phones do video all the time. Like your smartphone has a really good camera, and they can't use USB either. So we've kind of solved this problem already in phones. We just don't have a plug for it on the outside, and I think that'll change at some point soon, because it's just a plug. And then at that point, you can kind of put any kind of cameras you want on these, and that's going to be really cool. And 2015, 2017, that's kind of the time frame we're starting to see them already. So the sensors. When these things actually become mobile, like you realize, well, I probably don't want to carry a wheel around with me. Joysticks, mice, keyboards, not mobile enough when you're walking around. Holdable controllers are still cool, but they need to become wireless and potentially wearable. Because if I'm carrying this thing around with me all the time, I don't want like Wiimote holsters, where like I get my Wiimotes out if I need to use VR all of a sudden. So there's a problem there, and actually someone's got to solve that. But the touchless sensors will continue to expand in breadth and scope. And I don't want to just say hand tracking. Hand tracking is awesome, but like you got to think a little bit wider than that if you want to kind of imagine what this is going to be. Like, not just hand tracking, eye tracking, body tracking, head tracking, object tracking, mouth tracking, environment tracking, and like voice recognition all together. And basically what that is, you get a fusion of all these input modalities that'll like basically allow for a totally new type of computing. And it's kind of a big deal. No one's really thinking about it yet. But it's sort of just natural. Like that's just what's going to happen. Software is going to be playing catch up because of that. I think that'll actually be the biggest limit in this generation. More people's thinking more than the hardware or the software on the back end. But that'll happen too. So you've kind of seen these. This is starting to look older now, but phone, magnifying glasses, some kind of camera thing, battery pack, etc. And I'll show you Generation 3 one soon, so it'll be less boring. Sorry, I was showing this a month ago. So why can't we use phone cameras? Might be wondering. Well, it's because the phone camera is really, really tiny. Like it's 60 degrees, and you've got like 100 degrees. So you're looking, unless you want to look through a toilet paper roll, you kind of need a wide field of view. And if you only have one camera, it's really bad. Like, I can't express how bad it is. Basically, imagine you have hand tracking, so you're interacting in 3D, and then you want to see through the headset, and everything you're seeing through the headset is 2D. So it feels like you're watching a movie. It feels like you're watching an IMAX of your hands, but you're trying to interact with the world through an IMAX screen. It's very weird and not real. So these headsets need VR-specific cameras, and that's what the Dragonfly was. Anyway, let's talk about Generation 3. So now we're untethered, and we're getting to small form factors. We're still single devices, but the small form factors come from basically a confluence or a fusion of custom displays, custom optics, custom sensors. Because at this point, people are saying, "I don't want to just use my phone. I don't want to use my phone for everything. I want like a real device that's made for this." When you do that, you start getting lots of things that you didn't get before, like transparency. There's no reason why screens have to be opaque. And so the second you start making screens for this type of thing, you get that. They'll be portable. They'll, in some sense, be fashionable, but it will vary. It will get better. The wild card is who is going to reinvent themselves to drive these spaces. There's lots of startups doing it right now. There's some big companies starting to do it. But a lot of companies had a really hard time going from PC to mobile. And going from mobile to this will be, I think, significantly more traumatic. So that'll be interesting. And now let me show you what a few of these look like. I'm not breaking any NDAs here. So you can probably find most of these on the internet if you really look hard. But I can't show you any of my favorites. So this is cool. This is called this is a Generation 3. This is an example of a Generation 3 I haven't displayed. It uses something called a fiber optic collimator. And so what these are little bundles of fiber optics. Basically, imagine like a fiber optic tube, and then you carve it out, and this basically makes a flat screen into a sort of virtual curved screen, which removes a lot of the optical difficulties in making something thin. And then you just put a normal lens on here, and then you put in the whole thing, and you get something that's kind of interesting looking that, by comparison, is much smaller than what we're used to seeing today. That one's opaque. Looks okay. Here's another one. This is a holographic OLED display. So what you see here is basically you have little OLEDs that are embedded in a piece of plastic substrate, and they shoot out, and then they reflect off holographic coating that then bounces it back and focuses it into your eye. And it's transparent. And they look like this. They're pretty, they're in a prototype stage. So that looks better. It's interesting, a little bit, colorful, but we're on our way to cool. And now you're wondering, like, the Leap, everyone usually says that the Leap Motion is super small, but look at this thing. Where am I going to put a camera on? Like, you have, the sensors have to evolve too, and so they're going to get really small. Here's a picture of one. You guys might not have seen these before. These are called wafer-level cameras. So this is a pencil tip, and this is an actual camera. And what it works is you basically have a chip, and then you have little spacers and lenses, and they stack them all on top of each other, and it's like 3 millimeters thick. That might seem a little big for some of them, but then check out this one. So that's another. These are all like stuff that you can get right now. This is not stuff that like people haven't made yet. So these get small, and those have to track hands and environments and cats or whatever you want to interact with. So you're starting to realize when you get to Generation 3 sensors, they're getting tiny. And when you get tiny, they're going to get ubiquitous. The smaller the head-on display, the smaller the sensors need to be. The average size, I think, will be like 3 by 3 by 3 millimeter for something that needs to track a hand. You'll probably be able to get up to a 10 by 10 by 5, but that's really, you need like Ray-Bans. Like, you can't have like sunglasses if you're going to go that size. These things, we're going to start getting sort of ASICs at this point, which are like specialized chips that make the motion sensing sort of all happen on a tiny circuit. And basically, so you don't need to use like a big CPU. And so once you have those, you realize, well, I could just take a sensor and I could take one of these ASICs and I could just have a standalone motion sensing device, like without a head-mounted display. So basically, and I can start peppering these everywhere, and people will. basically any situation where it makes sense. So imagine a 3x3x3 millimeter thing with a little chip, probably going to cost a couple dollars. It's like almost cheaper than a light switch, but it can track a hand with like full skeletal precision. So we're looking at some weird stuff pretty soon. You can imagine things like light bulbs becoming significantly more sophisticated than like a Kinect 2, because there's no reason why they can't. All the sensors are getting there very quickly. And with the processing on board, you can have fully contextualized skeletal tracking with gestures and everything wirelessly transmitted to anything nearby that wants to or has permission to have it. I guess one last crazy one. To get a sense of what this might look like, I have a kind of a little ghetto picture. So here's a 10-piece sensor array. And so you've got some sensors looking down, some sensors looking up, sensors looking sideways, some looking forward, and there's actually some looking at your eyes too. And so imagine something like a 260 by 220 degree field of view, where basically everything that's around you can immediately track, both your environment and even your mouth and feet, because you got some stuff looking down. And that, mouth tracking sounds stupid, but it's cool for two reasons. One is like better voice recognition, and the other one is like you want avatars, right? And so if you want, if you had actual mouth tracking, like your avatar would probably you could like smile and stuff, which, I don't know, maybe that's a thing. So yeah, and a lot of other things like people want, like, you'll be able to track everything from like maybe 10 centimeters away to like 5 meters away simultaneously. So it's kind of like high dynamic range finding, which is cool. I just made that up as a term, but it will happen, and this is the sort of stuff that we talk to people about all the time. Yeah, so sort of in summary, the potential for change is profound and surreal. You might have missed it. I kind of breezed over a little bit here, but like I said, that these Gen 3 things, 2016 to 2019, so you start to realize like every one of these generations I just sort of breezed through have the ability to appear within 1 year of the other, and you could almost freak out about that, but it's going to happen. And what we basically have is we have this sort of ubiquity and portability of the mobile era meeting the most deeply immersive technologies we can muster as a species. Kind of scary. Usually the dangers of that can only be eclipsed by like the raw potential for evolution and expansion in the same way. So I usually end this with just saying, won't that be fun? And that's my talk.
Thank you.
I gave you a little bit of extra time.
Perfect time.
We'll make up for it in questions.
We're running right on time here. Perfect. Okay. So after the next talk, we'll have a Q&A opportunity for all the speakers. So they'll all come up here, and we'll have about 15, 20 minutes for Q&A. And then we'll have the raffle prizes. We got a few extra raffle prizes. 3 more Leap Motions have joined, and a couple of new laptop sleeves as well. Okay. All right. So all of these talks are recorded. Tonight is live streamed, but it's always recorded. You can find the recordings at bit.ly SFHTML5 videos. That's as an archive of all the different videos that we've ever produced for the last almost 5 years. All right. Looks like we're in business.
Don't look. You're gonna spoil.
Do not look.
Are we on the right screens here? You guys are getting the fast forward. Okay, cool.
All right.
We're here. Yay. Thanks for sticking around, guys and ladies. I'm Patrick from DodoCase. For those who don't know, we've been doing cardboard VR stuff since like 2 hours after Google announced it at the I/O event. We were like the first ones to hop on making this a product that people could buy. We recently did a Kickstarter with Tony Parisi to fund the development of some virtual reality features into the GLAM platform. DIY VR, do-it-yourself virtual reality. And also, actually, a component of that was also bringing, is this volume all right for everybody? Is this working? Yeah, okay. We also had a Leap Motion mount that you could build right into the cardboard. So you could do all the like sexy hand gesturing stuff, plus hands-free because we had this cool hat mount thing. And it was, it looked kind of cool. So anyway, what I really want to espouse here today is that this is the homebrew moment for virtual reality. There are like 2 billion people walking around with smartphones that are actually virtual reality devices, and they just don't know it yet. And all they need to transform those devices into VR is a cardboard box and a couple lenses. That's pretty amazing. So great things happen when you drop barriers. And one of my favorite stories is during our Kickstarter, we had a guy from the UK. He was a 15-year-old kid. His name's Matthew Timmons Browns. He's got a great website. It's right there. You can go check it out, the Raspberry Pi Guy. He makes these video tutorials on how to do stuff with the Raspberry Pi, which is this really simple computer. And he reached out and he was like, hey, I love this idea. I want to make a telepresence virtual reality controlled robot using the Pi2Go robotics platform. So this thing all in, not including the smartphone, costs less than $100. And this is a 15-year-old kid in the UK building a virtual reality controlled robot that costs less than $100. I mean, that's the power of making things accessible and open and getting lots of people thinking about virtual reality and new ideas of what we could do with it, solving problems. I really want to inspire people here, hopefully, that you don't have to have a lot of money to get into this. It's going to take a lot of mistakes. It's going to take a lot of experimenting to figure out all the things that are going to make virtual reality really stick. And 1 million people with $20 can achieve just as much, if not more, than a few people with billions of dollars. So don't be intimidated. Build the future you want to see. You guys and ladies in the room and hopefully watching this podcast, you really have the skills to make this possible, right? We've done a lot to get rid of the hardware barriers for people to get their hands on virtual reality, but there's still a lot of software barriers. We heard a good amount about that from Tony and the others presenting. It's expensive and difficult to get the tools. They're not, you're playing in other people's walled gardens. So what can we do to drop those software barriers? Well, we think that this DIY VR revolution that we're trying to champion should really have an open technology stack. We want to see VR be more like the internet than a game console. The internet is a powerful thing because it's this open platform that anybody can publish to, that the tools are free to use, HTML, CSS, and JavaScript, and you're in and you're going. So we want to make the tools for creating these VR experiences a lot easier. And we think the platform is going to be a whole lot more powerful and live up to its potential if it's built on an inherently interconnected system. These kind of idea of going between mobile apps on your phone is really siloed, and it's going to be difficult for VR to, I think, be the powerful medium it could be if the experiences don't flow into one another. And so I think that's really important. Also, there's more web developers in the world than any other type of developer. So if we build these tools that this community can use to start building basic virtual reality experiences, we're going to have more people experimenting and figuring it out and making the mistakes, and that'll help accelerate things to a whole lot. We'll get there a whole lot faster, I guess is what I'm trying to say. So that's why we're a part of helping fund the VR development of the GlamJS platform. And if you want to check it out, you can go to glamjs.org. I'm not a developer, so I can't really answer technical questions on it. But we have started dog fooding kind of the platform, and we're going to do. So this is sorry, yeah. So in summary, like virtual reality deserves an open and free future, and it'll be a way more powerful technology. It will shift from being a technology to really being a media and a medium of human exchange if it is open and collaborative instead of locked down and controlled. It wasn't too long ago that everyone was getting their minutes for the internet on these little shiny CD things, and AOL was, the internet belonged to AOL. I mean, that, nobody likes that future. It slowed things down. Luckily, we got past it, but, it's the risk of having closed platforms. So I'm going to do a little demo. Today, we pushed into production the latest version of the DodoCase virtual reality app on the Android platform. So if you want to get it, you can go to that URL. We built the app using WebGL and the GLAM tools that Tony's been working on, and it's running inside a crosswalk. So it's a native app, but let's see if we can get this demo working. It is built with WebGL. All right, let's see. Okay, we got the camera. So the basics, and I apologize ahead of time. This is a little bit, the camera resolution's a little bit off here, but we'll make do. So as soon as you rotate the application or rotate the phone, you'll enter virtual reality mode. You'll see the head tracking working. What you're seeing there is a bunch of planets. Each one represents a category of apps. So if we look at the games planet, and then we touch the screen, we'll zoom in on that set of apps, and they'll start to present themselves in a way that we can select them. This is forward, home, if we want to zoom back out and go around. And so these are, we've kind of pulled together all of the virtual reality applications on the Android platform in one place so people can find them more easily. Also start learning about these tools. So I encourage you to, that demo is a little hard to see, so I encourage you to go check out the app if you can, bit.ly Dodo VR app. And I wanted to spend the second half of the talk looking at, how fast is virtual reality going to get here? We've heard a lot of numbers, a lot of exciting stuff. 500,000 cardboard viewers out there, and it's been just about 6 months. That's pretty phenomenal. It was, just for kind of a reference point, it was Oculus is acquired 2 years after their Kickstarter, and they had sold 75,000 Oculuses. They hadn't actually shipped them. They'd sold them. So, for reference, like, that's a huge difference in number, right? So if you just took those 2 data points, it seems like things are really accelerating. What I like to look at, and I've done this in a couple presentations before, is, virtual reality is the next kind of format, or not, I don't even call it a format. It's the next medium, right? So we had books, we had written word, then we had radio, then we had television. Each thing added another kind of dimension of interaction or had its own unique things, and then the internet. And those have been kind of the major mediums of exchange and media categories. And so virtual reality is the next media category. How fast did those technologies transfer into becoming massively adopted? So let's look at the radio to start with, right? Interestingly, the radio, the first radios for consumers were made from cardboard oatmeal tubes. So you're looking here is a diagram from a government document that was like handed out because everybody wanted a radio, but they were really expensive. How to build your own radio at home, kind of DIY style, right? In the early 20s or whatever. And that cylinder thing right there you see is actually an oatmeal cardboard tube. So the radio in 1920s started to become a consumer technology. It was around before then, but it was really used as like a wireless, like a wireless telegram. Like you see this pattern emerge too, where like the latest medium kind of tries to like copy what came before it until people figure it out. So the radio was like, oh, people are used to sending letters. Well, now we can send letters faster. We'll send them using this radio thing. And, it wasn't for a couple of years until people really figured out, oh, the real consumer application for radio is, building stations and broadcasting music and news and all that kind of stuff. And it took 38 years to reach 50 million users of radio. And in today's dollars, a radio back then cost $300 to $4,000. You can see why people would want to build their own. I mean, interestingly, $300 to $1,000 is like kind of where VR, expensive VR stuff is today. The television came around in 1939. Actually, a lot of the same players in the radio space were the ones who saw the opportunity for television. First consumer television sold in 1939 for $10,000. Hugely expensive. It took 14 years to reach 50 million users. The internet. First really publicly available consumer version of the internet, 1991. Took 4 years to reach 50 million users. And I like to pause here and think about the kind of analogies between where we are with VR and smartphones and also where the internet was in 1991. Because the PC, I think, was really this important enabler of the internet. You had enough people with PCs at that point that the internet coming around just at that right moment and people only needing to add a small piece of technology to get on the web, like it was like a flash. It happened so quickly, right? And so if you look at today, there's this mass adoption of smartphones, and kind of this cardboard box is almost like the router of the 1991, right? It's even cheaper than a router, but it's just a small additional component, and you've unlocked this whole new massively interesting experience. And it's almost like, the other thing that I like to think about, and I find interesting, is the browser on PCs also kind of was like this Trojan horse into like taking over your PC, right? Like the PC operating system used to hold like an iron fist on the whole computer industry, and then the browser came along, and now people, that's all they want to use, right? The internet is like the killer application for your PC. Well, maybe VR is going to be the killer application for your phone. Maybe that's like the sneak attack on the phone operating system. I don't know. But anyway, moving on. So what is that? If you notice a trend here, each one happened like 3 times faster than the last one. So, we've got smartphone-based virtual reality. It's super consumer friendly. It's ready for prime time. People, I can hand it to my grandma. I can hand it to my mom. They try it on. They're like, wow, this is awesome. It's not confusing. Everyone's got these smartphones. So what does that mean? If we look at the timeline, July 2014, how long is it going to take to get to 50 million users? If it happens 3 times faster than 4 years, it's like 18 months. Like, that's nuts. If that happens, incredible. I mean, you could see the path to how it could happen. I do think it's going to happen. But it's, we're at 500,000 now. If it's exponential, 2 billion smartphones in the world, it's actually just a small fraction of the smartphones in the world to get to 50 million people using VR. So that's it for me. I'm happy to answer questions. I think we're going to have everyone come up now and going to do a group discussion, but I'm happy to answer questions until the point when people are ready to come up. So, also I've got some swag for the first 2 people to ask questions to incentivize you. 2 DIY VR hats. Yes.
What's the 2525 for?
Oh, that's our address. 2525 3rd Street. Good eye. Here, you get a hat. Ready? All right. Yes.
Well, is your VR, the headset, the cardboard in the box, different than the Google one? If
Yeah.
it is different, what's different about it, and how much does it cost?
Okay, good question. Hat for you. So our VR viewers, we've gone through actually 3 iterations. The first one was based on Google's design. The second one, we really wanted to figure out how to solve the problem of input. The magnet button on Google's design only works with about 4 Android phones that have the compass in the right quadrant of the phone. It's not very. It was also very reliable. So we figured out a capacitive touch button mechanism. So when you click this button on the right, it actually touches the screen and acts as like a finger touch. So when you look at something and then you click this button, it can select it, and it works with any phone that has a touch screen, which is basically all smartphones, right? So, and then, well, let's say we did 3.5 versions. Then we did our developer cardboard kit for the DIY VR. This is all in the span of like 6 months, just so people get a reference. We did like 3 product iterations in 6 months. We also published a beginner's guide book, which you can go get in Barnes & Noble. It comes with a virtual reality kit. And we did this, and we did our app store so that people can find the content more easily. So it's been a busy six months. But yeah, and then the DIY VR cardboard developer kit has both the magnet and the capacitive touch button and the leap motion mount on the front, and then comes with a hat mount, which I've got around here somewhere, so you can. Yeah, sure. So the so this is our hat, we call it the trucker hat mounted display system. So you just throw your hat brim in like that, and then put it on, and I need my, is there a VR viewer over there? I think I forgot. Oh, no, here it is. It's hiding. So then your viewer just goes like this, and boom. There you go. There you go. Yeah. So, and you can slide it and adjust it. It comes in and out, and it's got input, like it's got cutouts for both the input mechanisms. And then this was our 3rd version, which is designed for the promotional and marketing industry. So if you got a piece of content you want to show people, and you want to hand out VR viewers pre-assembled and everything, it comes flat packed in a box and just pops up like this, and boom, you got yourself a virtual reality device. So we have on our website there $25. dotocase.com. So any other question? I mean, I think you guys can keep asking questions because they're going to bring up chairs, and this will happen. Yeah, in the back over there. So the question was, what did we build our app store on? So we, for the application, we used Crosswalk, and then it's built using Glam, and so that's, Tony can better answer that question. Maybe he can answer it in more detail when he comes up on the stage here. But it's a Crosswalk. It's running inside a Crosswalk, so it's basically a browser. I'll let Tony answer that question. Oh, so how similar is that to any 3D modeling software? Is that what you asked? Yeah. I'll let Tony answer that question because he'd know better than I would. He's waiting. He'll answer it in 1 second here.
Speakers can come on up. Speakers.
Oh, thanks. All right. Cool. Thanks.
Hello.
Yeah, thanks.
All right, the other speakers can come on up. And if you have a question, we have a mic in the middle. So just walk up to that and ask away. Yeah, we'll dim the lights.
You still got the lab? Good.
Oh, yeah. Am I okay with this lab?
You got the lab, right.
Oh, one other cool thing is there's all these cameras that are coming out now that are 360-degree cameras that are like consumer grade. So you can buy a couple $100 camera and actually do your own live capture VR. This is one that I was playing with this holiday. It's Kodak. It has all the same GoPro mounts and everything, so you can stick it on your helmet, and it captures not a full 360 sphere, but 212 degrees. So it capture, if you wore it on your chest, it'd capture everything in front of you. The Gyroptic guys did a Kickstarter. I know they're launching their thing pretty soon. There's word that YouTube's going to support 360-degree video in the next coming months. That was an announcement out of CES. So there's a ton of stuff happening that it's going to make it consumer friendly for people to make their own VR content.
Ready to roll?
Yeah. Questions? Go ahead.
Well, hold on. Why don't I pick up with the just before we forget that previous question that was asked. So I kind of glossed over this. I was going through my stuff pretty quick in the beginning. So the idea behind GLAM is an easy way to put scenes together using markup. But under the covers, there's a lot going on. If any of you have built an application in WebGL, and Brandon flashed some raw WebGL code up on the screen, and then he showed 3.js after that, you know when you write WebGL, you're writing a lot of code. And if you write 3.js, a JavaScript library, you can write about 3 to 10 times less code than you would write in WebGL. But even with that, writing 3.js, it's a lot of work. And you find yourself doing a lot of the same things over and over again. And it's not structured. It's not declared in a way that you can then query it, index it, and do all these other wonderful things that we can do with markup. So I created this markup system for making 3D content. So it's not specifically like modeling software. It's more like the interactive layer, like building things in HTML and CSS. The actual 3D assets then can get created in code, using 3.js to programmatically make your geometry, or loading in files from OBJs or Collada or STL or these other 3D formats that are out there. So I hope that gave at least a partial answer to your question.
Hello, Tony, Josh, David, Patrick, Brandon.
Right.
So if I were an investor, and I'm not, but if I were one, and I was looking at 2 virtual reality startups, right? And the teams are similar, the products are similar, but the way in which they differ is one of them is open source and the other one is closed. Why would I go with the open source startup?
I think it really depends on what they're building, what the product is. You know, it's a.
Can you expand on the from an investment point of view, what are the advantages of the open source style or route?
Well, I think that the answer still is it depends on the product, because open source can be very, very advantageous for certain types of products, especially. So we like to talk about the metaverse or the Matrix, stuff like that, and what's the other book? Ready Player One. I forget what they call it in there. Oasis. That was actually a big part of the storyline, was the fact that Oasis was an open source platform. Nobody owned it. There was one company that was running it, but anybody could contribute to it. And that's what made it what it was in the story. Now, obviously, this is a fictional book, but we see that same pattern play out in the real world where, if something's closed source, then you've got one company that can put it out and it can be the most awesome thing ever, but eventually that company's going to lose interest, support's going to die off, and unless they do something drastic at the end of life, like open source it, it'll eventually fade away. Whereas, open source projects can grow this life of their own that just goes on and wildly exceeds the creator's expectations. I'm going to use a closed source example as an open source, but Minecraft. So Minecraft is Java, so it is open source, no matter what anybody else wants to tell you. And if not for the fact that players could get to the code and modify it in some way, shape, or form, I don't believe that Minecraft would be what it is today. Microsoft would not have bought it for $2 billion. It's because the community can contribute that makes these products what they are. And so if that's the type of product you want to build, of course it has to be open source. But if you want to build something that's more like your standard traditional commercial AAA game, then yeah, good for you.
Thank you, guys.
Yeah.
No, that's it.
Hello. So there's been a lot of attempts to sort of optimize the way that we interact with computers. And with that, there's been ergonomic keyboards and stuff like that. But with something like Leap Motion, where the granularity of control that you have and being able to articulate certain things, do you guys foresee a future where things like Leap Motion would replace more legacy input options like a mouse and keyboard?
The Leap Motion was not meant to sort of immediately destroy all other input devices. Some people will say there was, it wasn't. So I guess, are you specifically for virtual reality or in general, or?
Yeah, more in general applications.
Okay. So as computing becomes more mobile, obviously, like these older input devices start to fade away. Like there's no mouse on your phone because you're not going to carry on a mouse with you, and the you can argue whether or not it has a keyboard. So I think as we get the thing that I see that happens probably, I think that's probably going to win or happen soonest is we're going to get these really good transparent worn displays, and so you're going to need to have some kind of input device that follows you around with that. You take your hands everywhere you go, so there's something to be said about that. But also there'll be a lot of sort of objects and environmental stuff too. So like maybe I look at my table and I have like a whole touch interface on my table and I can do my 2010 era smart typing on there. Or maybe I have this sort of mouth tracking enhanced voice, and there's a whole lot of things that you'll probably see. So multimodal interfaces will probably kill all of these old sort of single modal interfaces. Does that answer your question?
Yeah. Thank you.
Mm-hmm.
Yeah, so I had a question about security. I came out of the horrible world of the download monetization, and which was kind of a result of Web 2.0, the idea of everything should be free. And so I'd like to know what you can do, one, to protect the content creators, so they can get value out of their content. And secondly, what are you going to do to protect the consumer from the things that happen in downloads where you get spyware, toolbars you really don't want popping up in the virtual world?
This is so beyond my pay grade. But what I would do as the head of security at Mozilla, I can't speak to I mean, actually, my first reaction is the response may be similar to what we have. I don't know if virtual reality fundamentally changes the security model, for example, at the deep layer. Again, it's so far beyond my pay grade. But with the user agent, I do think there are opportunities to make it appealing to eat your vegetables. I've tried to make people care about security in a 2D browser. It's hard. It's an abstract notion. It's complicated. Even if you do care, it's not necessarily effective, and it's got a bad rap for any number of reasons, starting with McAfee and shit like that. But in virtual reality, maybe we can anthropomorphize things, as I was saying in my talk. There might be an opportunity here to make security actually fun, and to kind of abuse a well-worn term, maybe to gamify it a little bit. And maybe that becomes a basis of competition between browsers. So maybe there's one browser that gamifies security and makes you care about it because it's just fun. It's part of why you actually use the browser. When I was thinking about, what would a VR browser look like, I was looking at things like Minecraft and things like that and trying to think of the engagement curve and kind of the first 50 seconds of your experience and then what you're going to be experiencing 3 hours later and 3 weeks later. And maybe one of the ways we make browsers kind of interactive and fun, maybe the kind of creepy crawlies you get in the first night in Minecraft are trackers. And you're kind of swatting away at them. You're like, what the fuck are these things, Sorry for the kids watching at home. I think there's a lot of opportunities there to from a user experience standpoint, to make people care about something that has been hard to make them care about in the past.
Yeah, so adding my expertise as the head of security at Google, which I'm not, for one, just know that security is absolutely the top priority of I think any of the browsers right now, and if I cannot convince the security guys that WebVR is secure, it's not going to go into the browser, like point blank. That's the onus is on us as developers to make sure it's secure. We have a great security team who is really, really anal. And they need to be. It's their job to be. And so, and on the browser side, like if you look at a lot of the forums that are built up around like the Oculus community right now, there is a whole bunch of them that have these developers who are super eager to experiment and do these UI or animation experiments, and they're like, oh yeah, check out this player character model that I put, and I have this eye tracking in there, and they link to something off of mega.co that's a 300 megabyte Unity native download, and it would be really hard to be less secure than that. So, the browser is all about security, and that will carry through into whatever form VR takes there. On the monetization side, I've actually blogged about this a little bit. It's hard for, I think, content creators coming from more traditional media to look at it and say, I can't encrypt my content. I can't, DRM is a very tricky thing on the web. But it's really a question of, what are you trying to protect? Are you trying to protect art assets? Maybe. And that's difficult on the web, no question. But oftentimes, I think what you're trying to protect is the overall experience. And that's something that you provide through your servers, and you provide through your customer support, and you provide through your services. And those are things that are very difficult to steal. And so that's the direction I see, not just VR, but all content on the web going.
I'd just add to that. I mean, if you look at every major medium, one of the foundational bedrocks of monetizing it is advertising, right? I mean, that doesn't even exist in VR yet. So that there are huge holes and opportunities all over the place if VR really as it starts to accelerate. So somebody's got to figure that out.
Right. I was wondering about the transformations that are required for the eyes towards the bulging out that was talked about. Is that just a mathematical change, like based on the form factor of our lenses in our eyes? And how much diversity is there between people? Are some people going to get sick around that, or how does that work?
Yeah, so that's a really excellent question, and I completely skimmed over it in my presentation. It depends, and what we're seeing right now is kind of an evolution of how this works. If you look at where the original Oculus DK1 was versus what DK2 is doing versus what Cardboard's doing versus what like Crescent Bay or Sony Morpheus are doing with their lenses, there's a huge variety of them out there, and they're not always things that can be like really cleanly described. In nice mathematical terms, sometimes you need like lookup tables and whatnot. And the goal of WebVR is to make sure that you never have to worry about that as much as possible. So a good example of how we're doing this on the Oculus side is when you set up your Oculus Rift, you go through a configuration utility and you do a quick little test, and it sets up what your IPD is. They've done all the work, all the hard magic to come up with the algorithms that describe how the distortion looks from your particular eye viewpoints. And then they return to me in the browser a mesh that describes how that distortion works. I then take the texture that you rendered through WebGL, apply it against that mesh, do any little like time warpy distortions that we need to do, and present that to the screen. So really the hard work there is being done by the person who made the headset, and they're the people that are in the best position to know. And if they do a crummy job, unfortunately it's going to kind of come out crummy, but thus far, especially Oculus and the Cardboard team, they know what they're doing, and it's working out well.
Thank you.
Cool. Start this thing. Hi, my name is Suyasha, and I like to do a lot of creative coding, and I'm super excited about using web programming skills and doing something in virtual reality. A few questions. First of all, I'd like to thank DIY VR for the hat, and especially I like the VR mount because I had another cardboard in the box, but it's such a pain to just keep holding it on with the phone inside it. Oh. And the mount is like, it makes it easy. My question is, can you give us some examples of apps you've seen or ideas? Like I've seen a lot of games, but besides games, because I don't develop games, I don't develop on Unity yet, but I may have to learn it. But anything else I can do on VR besides game? The person from Mozilla, he showed the Wikipedia on it. I personally wouldn't want to make an app that you're reading a bunch of text on a head-mounted device. It's better to read it on the laptop or something like that. But anything regarding where you are actually leveraging VR capability and rich multimedia?
Well, just to pick up on your Wikipedia example for a second, I agree. You don't want to be sitting there just looking around at a bunch of flat pages up in front of you in 3D necessarily. And especially you don't want to do that in the near term because text rendering just isn't that great yet, as Josh was alluding to, though it will get great soon. But imagine, if you will, you want to learn about the universe. Now you're in a virtual reality simulation where you're flying through the solar system and you're flying through our galaxies and you're learning about physics. Imagine Cosmos, the TV series, either the original one or the remade one. Imagine being able to do that in virtual reality. But then now when you want to get some more information on anything you're looking at, there's just, the Wikipedia page is just a touch away and now it can pop up. Hopefully, well rendered because someone's made the VR-ready version of that Wikipedia page. It's just got, enough lines of text to give you the information, but it's not going to kill you with crappy text. So now, just, imagine that now. It's the same application as Wikipedia, but in a completely different presentation. That's just one example.
I'd say there's also, a lot of live content right now that's coming out. Jaunt has published a bunch of concert footage. You're on stage with Paul McCartney or Jack White. Grade A, content. Autodesk is doing really interesting things where they're letting using their CAD software. They're letting the WebGL. They're basically passing that CAD information into WebGL format, so you could start looking at 3D models for architecture or other applications like that. One of the fun applications I've used that my friends have kind of been surprised with, the photosphere feature on your Google Camera app. If you take a 360-degree photo with that, you can view it in Cardboard VR. So it's the simplest way for you to create your own VR content ever. And I've done that at my friends' weddings, and they lose their shit. They're blown away.
The thing I'd add to that too, was this on? Don't get too hung up on the front end. That's the least important part. Think about the job to be done. Why do you go to Wikipedia? Why do you go to YouTube? Why do you go to a porn site? Why do you socialize with your friend? I'm quite serious. Do not get caught up on the front-end manifestation of the current web. That is the least important part. It's the easiest part to swap out. Just think about what makes the web special at a very deep architectural level. And then think about the jobs you hire the web to do. So Wikipedia, for example, if we're hiring it for education, well, that could be me with my class stepping into a representation of Muir Woods with my teacher being there, and maybe little minor excerpts of data being fed in an opportunistic fashion through an open Wikipedia API. So leveraging the web we have and synthesizing new experiences from it on the fly while staying true to the same fundamental job that we hired that site to do, in this case, education. There's kind of a common, the most common thing we do when we see a new form factor or a new breakthrough in computing, whether it's desktop replacing mainframes or mobile replacing desktop, is we kind of have a struggle at the beginning to see what it's going to be good for. Focus on the fundamental strengths of the platform, plus the fundamental strengths of the new medium. And honestly, I tell you, we get in front of a whiteboard at Mozilla, we shake our sleeves, and 100 startups fall out. If you can't think of 100 ways to monetize this, you're hopeless. It's going to be easy.
Cool.
I see you there, and I want to give a really quick example of a very practical, real-world commercial application that you can see right now. There's a company called Matterport. I believe they're in Mountain View, and they do real estate walkthroughs. That's not all they do, but they have this basically a street view camera that they can take to your real estate listing, plop it around there, and they build a 3D model of your home. It's on the web. It's in WebGL. You can go to their site. It's Matterport.com, I think. And you can see this right now, and it is incredible. And they've experimented with they've been experimenting with VR. They've shown it off at a couple of meetups, and it is the most incredible thing ever to put on the headset and be I'm standing in somebody else's kitchen. And so you think about that in terms of, okay, if I'm browsing a site like Zillow and I'm scrolling down through the list and one of the listings has a button that says, walk through this home right now. And you click that button, what would you prefer to see? The thing come up and say, put on your headset and go? Or, so now if you go and download this Unity application and open this and then download this content pack, no. You don't want that. You want to be able to say, walk through now. And that's an incredibly compelling real-world commercial use that I think is going to be huge.
Yeah, I mean, and you've seen like these little plug-in things online where like people are clicking and dragging and they're trying to do 360, but it's in this little window inside of the window of your browser, inside of the window of your screen, and it like just looks awful, So like, figure out a way to get that content into like a VR mode. That would be great.
Okay.
Also, shameless plug, like the hat mount that you were excited about. We have a booth at the Upload VR event if you want to go and buy one with the hats too. Another reason to go there after this.
Cool. Thanks.
All right. Time for a few more questions. 6 minutes left. So.
1 minute
Minute each and a half.
Rapid fire.
How's it going, guys? My name's Ray Chardella. Thank you, by the way. This has been very informative. So I've been using 3D CAD software for industrial design for quite some time, and just recently I've decided to kind of pivot and use my 3D design skills for 3D interfacing, and VR really excites me. I went to the Samsung Developer Conference and got hands-on with the Gear VR, and I'm completely sold on the idea. So my question for you is, how can I translate my 3D CAD design skills into VR? I use Autodesk. I use Autodesk Inventor, so I would like to just code this and make it, VR ready.
Yeah. And if you look at Autodesk is like their developer network, there's stuff there that'll tell you like how to get it into WebGL. I can't speak specifically to it, but I know that those tools do exist.
Yeah, there's some. They're coming online. I mean, they have one online viewing product that can probably, I'm sure it reads Inventor files. We have an Autodesk rep here somewhere. Jim, are you here somewhere? You want to quickly answer that about Inventor files in WebGL? Developer.autodesk.com.
Okay.
I
just remembered I had a little brain freeze for a second.
Very quickly, you've done the hard part. 3D. That's the hard part. I keep telling my web designer colleagues, you're about to get your ass kicked by visual effects and game designer guys. They have skills that you do not have, and they're a lot harder to acquire. So it's easier for you to learn what I'm good at than it's easy for me to learn what you're good at. Put it that way, in my opinion. So 3D spatial thinking plus interface design, you're good to go. You'll be fine.
Thank you.
Just on a small note on that, like Mr. Doob also has like a lot of converters from different file formats, and there's also a nice online product for viewing 3D.js products called Verald that you can also check out. So Mike, I really liked your talks. So I'm a front-end guy, and my specialty is like interface. So the question's like really about text in 3D environments. Like I noticed in your talk, Josh, that you used what looked like to be like a plane over the actual 3D environment you're doing. So like text on the 3D environment's very clunky. Like either you have to like port it over from canvas, you have to do it as a plane, or do you have to actually do 3D text? Like, so what's coming in the future that will make this like less intensive on the actual client?
That's like, so TV comes out and they put, everyone knows the story. If TV comes out, they point cameras at news broadcasters and radio programs, right? It's kind of like this is the MVP of what you might use a TV camera for. That right there is like the MVP of how you might, in a judo kind of way, leverage existing content and make it work and for VR. I mean, I think it gets very hand-wavy very fast, but my previous comment, like, web design begins to look like architecture or urban planning pretty darn fast.
Yeah.
That will just be the beginning. So I wouldn't get too hung up on text. I would begin to think about collaborative experiences. So I didn't get into this, but I think that one thing that could make the web really special is if we can utilize things like WebRTC, and maybe collaborative browsing can become an integral part of what makes the web special. So WebRTC is a new real-time communication protocol for video and audio on the web. I want to integrate that deeply into a VR browsing experience. So again, you can go to your classroom, you can go to URL at 10:30, look around, your students are there, your teacher's there, and she guides you through an educational experience. So collaborative browsing, I think, could be huge. Text is kind of like, it's important. It's just the beginning. We'll do a lot more. I think creative people will do really cool stuff with it.
For sure. Thank you so much.
kind of think it's the other way. I think web VR, specifically in the browser, lets us actually do deep disruption of the real world. And I know one of my friends over at Magic Leap, that it's seriously, the reason KKR came in was not like the Me Too. They have deep physical and Qualcomm real world experiences, they think, from an e-commerce and strictly deep data IoT way they can actually disrupt the real world. So the things you're talking about collaborative browsing are the means to do that. Things like visual UIs with motion tied in with IoT data are actually going to let the web go away as being an obtrusive experience. The question is, how does web VR and things like high-speed devices and speed up the performance we need with maybe SSDs or whatever, or VM that actually works for SSDs to optimize for it, get us the performance we really need to do that? Because it literally has to process a lot of data faster than we can do. I mean, because that's the real problem we're having now.
I imagine we might start to see some things like, Apple had to rewrite a lot of stuff from scratch to get the good enough performance to do mobile early on. I think we're going to see something similar there, similar to that.
It's the only way to do it. Any questions?
So, boy, it's a complicated question. I mean, there's all sorts of issues that need to be overcome right now, just basic software issues. But there's also an entire class of issues that I see that are a matter of nobody has had a reason to care yet.
Right.
Nobody has had a reason to care that the accelerometer in your phone is really precise. And nobody's had a reason to care about screens that look good when you're right here. And nobody's had a reason to care about browsers that run at higher than 60 frames per second.
Yeah, because VR becomes a security issue. It's like a life and death palpitation,
exactly.
Kill you issue. Yeah.
So, well, I should hope not.
Well, if it's good, it should.
But yeah, I mean, it's just, I think that the long-term solution is just, as this becomes a popular medium, people will have a reason to care, and out of that comes improvements to the entire spectrum.
Exactly.
Last question.
Last question of the night. Thank you very much. It seems like the path of least resistance to creating content for VR is stereo shooting, whether it be just straight single point of view or 360 cameras. Those cameras, however, are all really expensive. And so, question for Patrick or for Brandon from Google: have you thought of making a cardboard stereo adapter so that I could capture content as well as consume it?
So actually, I don't think it's so much stereo, but like really wide angle. A lot of the video, like with this little camera, this is I think $299 camera. So in terms of camera tech, it's not that expensive, but it's the wide field of angle that it's not 3D, right? It's not stereographic in that way, but it's being able to move your head and not seeing the edge of your field of view. That in my observations, seeing people use VR for the first time, that's the wow factor for them. It's actually, they can't really even tell that it's 3D or not when they're looking at a video or a photo. Like, you can take a 2D photo and wrap it around a dome and do that for them. So I would say just a wide angle camera.
I'll be provocative for a second on that one, just
yeah, sure.
Because we're gonna have all these cameras on your head eventually. Like we have our Dragonfly prototype where it's literally 3K cameras where your eyes are, so you can just record, and you're recording what you're seeing, and if you plug that into somebody else's headset, you're just seeing what that person saw. And they're wider field of view too, so you can even pivot a little bit around inside of that once you have that aligned with the gyro. And you can imagine more and more cameras, if you actually care about video recording. And I think a lot of the sensors that are on these headsets will actually become sort of easy content import things. Like, imagine the future, you want your avatar to look like you take your headset off, you point it at your face, 3D scans your face, you put it back on, and now you have your face in VR. Stuff's going to happen.
Okay, thank you.
Yeah, one final thought to add to that is so doing stereoscopy in a photosphere or something like that is really hard, to the point of being literally physically impossible to get an optimal solution. If you want to read more about that, go to elevr.com, elevr.com, and read about the fuzzy ball problem. They actually do a really good job of explaining it. But there is an awful lot to be said for having just a monoscopic photosphere. And those are super easy to create. Pull out your Android phone and hit the photosphere, and you could create one of this room right now in 20 seconds.
Okay.
And
I'm going
they're
to do
great.
it right now.
Yeah, do it.
Those are great products, but just so you know, there was a company in Seattle, Poppy, that did this great little stereoscopic adapter for the iPhone. Sells it for $60. Does a terrific result. And there's a company in Iceland called Kula that's making a stereo adapter that's just a pair of mirrors that'll go on the iPhone. It works really, really well, but it could be $2 if somebody did it in cardboard.
So I've tried to use the Poppy thing for VR, and it actually fails because it doesn't give me a wide enough field of view.
Mm-hmm.
So,
That's solvable.
Yeah.
All right. With that, in 20 seconds, we had our picture. Okay, so I'd like to get a big round of applause for all of our speakers. We have a few speaker gifts. Our special SFHTML5 painting for you and a glass of wine. All right, so watch out for this one. All right, so we'd like to take a picture of all of you speakers over there with this camera. So with that, we're coming to the end of our program on the live stream. I want to thank everyone that's been sticking to this, sticking with us on the live stream. Thanks a lot. With that, we're going to close the live stream. We're going to go to the raffle, and we're going to do that pretty rapid fire.